Upon finishing that, I spent some time trying to get another job in geology, and managed to get a job working at Fugro, and I was there for about a year, working as a field, I was working as in a geotechnical laboratory, and that was logging cores that were coming in from offshore for wind farms, and also doing laboratory tests as well. And it was at that point I actually learned a lot more about what the tests were being used for. I learned a lot more about engineering geology. And I picked up that there's a number of master's courses that I was really interested in. And I joined the University of Leeds, graduating in 2015. During my time on that course, I soon realized it was important to start applying for jobs quite soon. Had an interview with Atkins at the time, and I got the position before I'd even sort of finished, on the caveat that I would obviously pass the master's course at the end. So it was really good to know that I had that comfort of I'd actually got a job at the end, as long as I managed to pass all my exams. So I joined as a graduate engineering geologist at Atkins in 2015. At Atkins, we have a graduate development program, has been mentioned before. And we've also got a ground engineering academy, which is something across all of our ground engineering teams across the UK. And we can get involved in, where we do specific training courses. And we also have a field trip that we have at the start of each year as well. So I was quite lucky enough to go to the north of France, South Wales and the Lake District in my 3 years that I was here. And that was looking at some of the sites that we're working on, learning about some of the projects and specific areas of ground engineering. And it was a fantastic way to sort of meet other people from across our offices and do some networking. Then became an assistant engineering geologist after some time, completed some ground investigation supervision. I got involved in a lot of geotechnical data management. One thing that's not really been discussed so much so far is the amount of data that comes with working in this area, whether that's ground investigation data, so laboratory test data, geomorphological data, geophysical data, and now with drones and things like that, there's a hell of a lot more data that we need to manage. So I became really involved in that, and I'm one of the administrators for our data management open ground library that we use. Obviously, done some interpretive report writing. There's a picture of a ground investigation there happening outside church, and that was for a flood alleviation scheme up in Mytholmroyd. Craig and I have good memories of a summer up there looking at those locations. And as I continued through my career at Atkins, I became chartered in 2021, I think, making use of COVID lockdowns to really knuckle down and do my chartership application. Some other examples of work: geomorphological mapping. I've then become a drone pilot. We're using remote sensing, so we're using data from drones and satellites, and using those on some of our ground engineering projects. A number of award entries that we've submitted across my time at Atkins, and obviously you get to attend a number of conferences and really good events like today. I've also had the opportunity to do some foreign travel as well. So the image from the previous screen and in the top right here is actually in the Albanian mountains. I was lucky enough to go out there, take a drone with me, and we were mapping, we were doing some terrain mapping and landslide mapping. And as you might be able to see there, but there's actually a large landslide complex that's running down the edge of the mountain there. A really amazing experience. I found it so useful to go out there, and using the drone as well allowed us to be able to map a much larger area of the site a lot quicker, and managed to get some really unique perspectives of the landslides out there. I've now continued to move on through my career, and from senior and recently principal engineering geologist, so I'm finding now that I'm actually got some line management, so I'm now managing people as well. So some of the new graduates have come in, I'm the line manager. There's a lot of project management as well, and bidding that I get involved with now. So there's just a bit of a transition as you sort of move on through your career. You get involved in those different areas. I'm not necessarily writing the reports anymore, but I'm checking them, I'm reviewing them. And then a note there along the bottom. I stayed at Atkins my entire career really since masters, but the face of Atkins has changed. In 2017, we were bought by a company called SNC-Lavalin, and only recently, so some of you may have recognized the name, but not Atkins Realis. Only recently we've rebranded as Atkins Realis. And in that time as well, I also moved offices from Warrington down to London. So it's a bit of an example of the abilities to sort of move around within the company as well. So that's it from me. Thank you very much.
Thanks, Adam. Last but not least, James.
Hi, so much like Giano, I'm also a consultant geophysicist at RSK and also a UEA alumni. So I did undergraduate in environmental geophysics, which I absolutely loved, but happened to be graduating in the first lockdown of COVID. So jobs were at a premium. I looked literally everywhere, applied for probably more than a dozen jobs, and no one was hiring by that point. So I thought, what better way to spend my COVID year of getting a degree in computer science? So a bit of a change, but geophysics has plenty of overlap with geophysics. So geophysics has plenty of overlap with computer science. So I thought I could add to my coding and then see if that's something I wanted to do. But I shortly found out that I didn't really enjoy just sitting at home, sitting on a laptop all day or sitting in an office all day. So I thought, as much as I enjoyed the computer science degree, let's move back to geophysics. Let's make sure when we're looking for jobs next, it's a job in geophysics. I think that was especially compounded by a field trip I did in my second year of university. We went to the Lake District and got to try out all of the different techniques. So whether that be GPR or microgravity or ERT, that sort of thing. And I absolutely loved that week. So I knew that was the career I wanted to go for. So I was applying for jobs halfway through my computer science degree and landed on RSK. So through the same application process that Giano was mentioning earlier, was applying for applied for RSK and got the job, which was really nice to know that before I'd finished my master's that I could move, straight away. Didn't have to worry about the dissertation or the quality of the mark I got. So it was nice to be compounded with that. So I joined RSK on exactly the same day as Giano, 15 minutes after, because he decided to turn up early. And then was immediately thrust in as into the RSK graduate scheme. So I was initially a safe ground engineer, which means, so for the guys at soil, so Eric was speaking earlier, we go and basically clear fields so they can drill their holes. But I knew that wasn't what I wanted to do. So I was able to have a conversation with my line manager. So I was able to move back into geophysics, what I knew I wanted to do. So the graduate scheme was quite broad. So it wasn't just geophysics. It involved report writing, social media, your CV. It was a really good experience to learn all of the different parts of the company. So after then doing the graduate scheme, after doing the graduate scheme, whilst doing the graduate scheme, I did lots of HS2, as Giano said. Basically all of the council bit up in Staffordshire for 6 months, doing lots of different geophysical work, GPR and then ERT, and then also rail work, so microgravity up in Leeds. So we were progressively getting more and more responsibilities whilst in our graduate scheme, and that ended up with we didn't need a senior geophysicist with us. We were able to carry out those survey works by ourselves. And then that led to me, after about 18 months, being promoted to a consultant geophysicist. So leading sites. So we did seismics on the M25. So all those, if you've ever driven, well, most of you won't have, but if you have driven around the M25 at middle of the night, occasionally roads will be closed, and that's because of us. We're doing MASWA, so basically hitting a sledgehammer on the ground, and we've got a load of sensors picking up the vibrations that it causes. And we did that for 3 nights, and it was an amazing experience. One that you think is quite scary, but actually completely fine. I've also had the chance to go abroad. So it's in the middle photo there. I went to Brno in the Czech Republic for a conference with one of our suppliers to look at their new bits of kit that they were developing. And then also more recently, we've been part of a collaboration project with the University of Glasgow. So that initially started in Kent, where we were doing downhole seismics, crosshole seismics, refraction MASWA. And then that moved on to works in Germany because they couldn't find another field in the UK for some reason, but wasn't complaining. We worked in this sand quarry for 3.5 weeks. We had a senior geophysicist with us for, say, the first week, but then they decided that we were quite competent by ourselves. So yeah, we're carrying out those surveys. Was a really good experience and nice to gain that experience. being a site lead. And that's kind of where I'm up to at the moment.
Thank you very much. So we've heard a little bit about all the panelists now. So now it's time for the panel session itself. So don't forget, Mentimeter, got questions? Fire them in. We've got some online already, so that's good. And if you fancy asking one in the room as well, then feel free. But we'll bring up the panelists first, and then we'll work our way through.
Patches. That's been used, John.
It's mine.
Oh, is that yours?
Yeah.
You bought one up.
Yeah, but I didn't bring a glass up.
Okay.
Yeah.
Have we got any questions in the
So
room?
I've got a question.
Okay.
So with it being digital geoscience, I think my main question was about where have you found, it's obviously for all of you, where have you found the most significant change with things like data management and AI and any kind of machine learning that you're starting to implement across your jobs?
Does anyone wants to take that one, or shall I go at Adam? I know that.
I can go first. Yeah. So AI is probably going to get mentioned a lot today. We are finding that we're using it more and more in what we do. An area that I'm finding quite useful at the moment is in terms of using remote sensing, going through a lot of satellite imagery data and digital surface models, and being able to use AI to pick out specific features. So if you're looking at things like sinkholes, you can actually use AI and a bit of machine learning to actually be able to pick out some of those features for you. Saves you a hell of a lot of time, and obviously you're checking a lot of these locations yourself, and finding that, for me, probably one of the most interesting and fastest changing areas of the way I'm working.
Anyone else want to add to that?
Yeah, so just as an example, I guess it's probably very niche and very small, but one of the very annoying jobs we have in Shallow Geophysical Survey is picking boulders. We collect a lot of lines of sonar data. We have to go through it, pick every contact that we see that looks like it's got some height, which is important for engineering purposes, but really laborious. And just in the time that I've been working, when I first started, I was doing that with a roll of paper sonar data, plotting it on a chart, writing down a list of coordinates. And now we're getting to a point where we've evolved through having the data digitally, picking it on a screen, measuring it, being able to go back and check it, and now developing software that can pick those boulders for us. And then all we need to do at the end is just check that they look sensible and it hasn't picked anything strange. So I think it sounds quite minor, but those advancements are happening everywhere. And as a overall change, that's making a huge difference.
Yeah, I'd agree with especially, well, we need people to go on site and collect data and do the field work. But when you go back to the office, especially with larger data sets, we're having more automated picking or automated picking for GPR, especially, and maybe even for seismics as well. So we need, when you got these big data sets, you need more development in geoscience to get it, in the data science to get it more automated, because it will take you a person days to pick something that AI can do in minutes or hours even.
Yeah, I'd say the same thing. So we've got ground penetrating radar software now that uses our picks from previous examples to pick our GPR data, which is can save a ridiculous amount of time and allow people to allow us to pick up more work and to do more of the interesting stuff. Because as much as it is fun, sitting down for 2 days and picking tiny little highlights in a bit of paper, it really isn't. It's useful having that AI to be able to do that.
I'd add to that AI is one of those tools which will help you do the things you enjoy more. So there are tasks which have been picked. The data is massive, and you finish projects and you'll have, on some projects we had sometimes 40 gigabytes worth of data just from one project, and people don't want to sit there and go through all that anymore. Whereas in the past, someone would be there trawling their way through Excel spreadsheets for weeks or months on end. So it's trying to make those tasks that we do have more fun, more challenging than the stuff we want to do. I'm going to move on to the next question, which is quite an interesting one. I think it's quite topical at the moment. So off the back of that one as well, a shameless plug for 2 weeks' time, here again for the Digital Geoscience Conference, which will touch quite a bit on AI and how all these digital tools are going to be used in the future and all that. So we'll come to that in a few weeks' time. But the next question, as a geologist straight from college, what is the roadmap to digital geoscience? So I know everyone's got a different way into what they class as digital geoscience is a bit different, but do we want to touch on how you've got to where you are now and how you've ended up with a digital career path? I'll start with you then, James.
So my career basically started from going to university open days and having a look around, and having a look at looking at open days, to gain an understanding of what you wanted to do. And then once you knew you wanted to go down that route, so data science or data in general, you're able to do that at university. So you pick specific modules. So geophysics is quite niche. We were able to do geophysics by picking at degree specifically, but I know a lot of universities don't offer that directly. So you have to pick the modules that suit what you want to do, if that is what you want to do. And then, looking for internships, looking for summer placements, and just making sure that is exactly what you want to do.
Yeah, I'd agree on like picking your modules at university. Like if you have opportunities to do coding, I'd definitely get into that. If that is the data science you can go into, really can help you out as well. Just like trying to find opportunities, because it is just trawling through lots of websites or LinkedIn and finding the job that you want, even if it's quite niche. And digital data science is like, I'd say it's still pretty up and coming. It's like with AI and technology as well improving so quickly, it is getting there slowly, and then more and more opportunities will be available in the future.
So Karine, would you say you came out of university with the digital skills, or is it something you learnt on the job?
Definitely something I learned on the job. I think the digital part of digital geoscience has evolved around me, and I've had to keep up, is probably a more accurate way of describing it. I definitely wish that I'd done a bit more on the computing side up front. But I think for me, it's been a learning curve as it's come into use, as it's kind of evolved together, whereas now you're going straight into a completely digital world, and it's only going to increase. So I think all of those kind of bit of computing, a bit of programming, a bit of GIS, all of that is going to help you.
Yeah, and I agree with the others here, just highlighting the fact to have a good look around at what actually degrees there are. There's plenty of them out there, and there's new ones popping up each day, each year. And there's definitely skills within those that can come into companies, whether that's sort of data science, whether that is coding. Sort of within my group, we're always in the need of coders and data scientists to help us manage our data and improve the way that we work. So there's lots of ways in which you can sort of go down the more digital route and then come back to ground engineering.
Yeah, I think that's mentioned it was very topical. There's different universities will have different levels of geoscience or digital skills being taught, and if you don't have it when you come out of university, it's not the end of the world. There are places you can go and you can do boot camps, you can do digital coding boot camps. There's all sorts of different ways of increasing that, and you can learn on the job as well. I've got next question, which has come in as a direct one for Karine.
Oh no.
How is it being a woman in an offshore environment, and what ways is it challenging? Any advice you have for women looking?
When I first started working offshore, terrible. Now, totally fine. Is the big difference. I did some stints where I was on a vessel of 40 or 50 people. I was the only woman on board. Some of the dinner table conversation was appalling after 4 weeks at sea. And that was a real struggle for me, genuinely. But now the industry is, we probably have more women in our geoscience department than men, I would say. It's even if not going the other way. And it really doesn't make any difference anymore. which I guess is where we all want to be.
Good. In terms of coding, what languages and skills would you recommend learning? So I think we've touched on this one earlier, but is there anything any advice you'd give to people at school, at university, and what they could learn now to get themselves ahead when it comes to career?
Python. Python's like quite simple and easy to learn, but also so versatile, and you can use it in so many different ways. If you're going to pick one, anyway.
I mean, Python's open source as well, so you don't have to spend a lot of money on installing on your computer at home, so you can get started whenever you like. Say another one that's quite good is MATLAB. We do a lot of our programming in MATLAB, but that does cost a fair amount of money. So if you've got a university subscription to it, definitely make use of that.
Yeah, I'd agree. There's plenty of free online resources for learning coding, and that is a good place to start. And even things like way back when I was at university, GIS was the thing that we got taught, and that's probably what the class is the only digital skill we got taught at university, but it's still used more than ever, and as it's been touched upon earlier, is really important for how we display and how we communicate. There's some of the key things if you can, and again, open source things like QGIS. It's a great one to learn, and to come to an interview with those skills is always an advantage. Any other questions in the room? So I've got a question for the geophysicists in the room. There's 3 on the stage at the moment. So I'm studying geology, but have developed an interest in geophysics as a career path. Do you have any advice for how I can make myself more desirable for geophysics despite not having a degree in it?
I think coding, if we're staying on the coding theme, you can pick up LinkedIn, do lots of tutorials and that sort of thing. So watch YouTube videos, make sure that you can pick up coding.
I guess it depends on the person, like showing like your transferable skills, because one of my colleagues is a geologist, even though he didn't do geophysics at uni, he did like a module or 2, but he wasn't a geophysicist by trade, but he's got the transferable skills of like project management, time management, being a team worker. And if you can showcase you've got those transferable skills, you can take yourself most places, really.
Yeah, I'd agree with that. I think if you haven't got the direct experience, then showing how the skills that you do have are going to apply to that role is always going to be the best way to go. And actually just showing that that's what you're really interested in doing. I mean, I'd rather have someone who doesn't have the experience and is enthusiastic than someone with lots of experience who's totally apathetic. So yeah, I think showing that enthusiasm is going to get you halfway there anyway.
So we've touched earlier on the energy transition about what the future might be like. And in our area of digital geoscience, how do you see your jobs changing? Is there anything that you look forward to in the future with it? Any things you think might be a challenge? I'm going to target that one towards Adam because he can speak about geophysics.
Yeah, so in terms of like the remote sensing and sort of the area around drones become so much cheaper to use and easier to use and more automated. We can use them more and more on our projects, and we can produce 3D models of our sites a lot easier than we used to be able to. And I see that as we progress further, we're going to be able to do that on a lot more sites, a lot more projects. It's going to be a lot more data to handle, but we'll be able to utilize that in a good way of communicating things to our client, but also using that data for analysis and assessments as well.
Yeah, we've talked a lot about, we keep throwing around the word data, but with improvements in technology, with new equipment coming in, everything is bigger, better, higher resolution. The data sets get huger and huger. And one of the real challenges is data storage, data management, just being able to transfer data around. I spent most of my weekend trying to upload 100 gigs of photos of the seabed over my, I thought, quite good internet connection, but turns out it takes a long time. So that is a real challenge of how do you deal with and store and move around and share these volumes of data.
Definitely agree with the last point. We've had issues a lot with how big our data is and being able to share it from office to office and having it on a shared cloud, and it's a lot of hassle getting it from uploading it and like downloading it and all that stuff. But one thing that we have realized in terms of the work we do is we're getting a lot more renewable work. So we're doing a lot more work for solar farms, wind farms, cables for wind farms and stuff like that. So that's more work that we're getting in that we haven't had in previous years before.
Yeah, I think in terms of the data, we are able to now collect so much more data because of just general storage devices and that sort of thing. But also we're collecting more data via different technology. So GPR used to be just push a cart across a field and hope you collect the data. But now we have, 16 antennas all on one device in different directions so that we're able to collect vastly more data than we have done previously, especially ones where we can put it on the back of vehicles. So yeah, we're collecting probably 10 times, 20 times as much data as if we were doing it by hand.
I think it also depends on the types of projects we're working on now as well, because especially in the marine sector, a lot of our work when I first started was oil and gas work, and it was small site surveys for rig emplacements, which were maybe like a kilometre square. And now we're doing wind farms, which are tens of or hundreds of square kilometres of data. So it's just the type of projects as well. Even if we're collecting the same exact data types, we're just covering such a vast area with it that just storing it and moving it around is a challenge without even trying to interpret it.
I think in general, we've touched on AI, and it's going to be a big thing, and well, it is already a big thing. We've got ChatGPT. How many people have used ChatGPT at university in here already? Or school? So seeing how things outside of geoscience are going to be used to help advance our own area as well. So there's lots and lots that have been going on in other parts of that aren't related to geoscience. So what can we learn from them? And that's the interesting thing about things like ChatGPT is where's the data come from. So we still need all these core geological skills to understand what is good, what is correct in the first place, and trying to teach and machine learning, making sure that the stuff that goes in is correct. So that's one area where it's going to change a little bit, where we use our skills now to make sure that the fundamentals are correct and that everything that gets put into these systems is correct in the first place, so that when people are asking ChatGPT a question about what the depth is to the center of the earth and all these things, that it's actually got the correct information. It's not someone going into Wikipedia and putting something that's fake news. So things will change, and there'll be different challenges that we face in making sure that AI is picking up the right information that's correct. So that, for me, I think that's one of the biggest things, and one of the ways we're going to see changes is how that happens. And got a few more questions on here. So we've got time for one more, I think. Do we have any advice for an A-level student choosing undergraduate degrees? Do they enjoy coding and interested in physical geography? Should they choose a coding route or go the subject route? Challenging question.
Yeah, that's a really hard question, especially as I switched courses halfway through. So I didn't even stick with my decision.
You did both.
Did both. You can do both. You can do an undergraduate in one and then a master's in the other.
There's such a variety of course programs out there now that you might find that you can find something broad enough where you can pick and choose modules that cover both things. I don't think you would have to hard and fast choose between the two.
There are degrees out there which look at geology and digital geoscience as an actual course on its own. But I'd say, as people have shown here, you learn on the job, and if you have something you want to do, if that is physical geography, you can do physical geography and learn those. Hopefully the university degree will teach you those skills, and you can find some degrees which will, but there's so many different options of learning on the job as well, or after hours if you're really keen as well. So there's ways. Pick what you're really into, and then you can maybe use it as an extra, but everyone will have their own way of doing things, and as proved, everyone has a different career path. No one has one set. Right. That's it. Thank you very much for the questions online and in person.
Thank you for the
Just announced that there's going to be lunch upstairs and downstairs.
Okay. So before everyone goes, the important bit, we've got lunch upstairs and downstairs, and we are back at 1 o'clock. 2 o'clock. 2 o'clock.
Yeah. Yeah.
Yeah, that's right. Yeah, like what?
This one? The green one.
Just give people a couple more minutes. It's not quite 2 o'clock on the clock there, so I think that was the 1 minute warning. Well, I don't know. Is that not Greenwich Mean Time, or it's about right? Right. Right, we good to go?
Giving you a quick
Okay.
tablet rundown.
I'll pass it
Yeah.
to you when it's time. Basically, all the questions will appear below these.
Okay. I can just choose any.
Yeah, relatively straightforward,
Yeah.
hopefully.
Okay, right.
Hmm.
Okay, good to go.
Okay. Right. Thanks everyone. And thanks for making it back from lunch. I hope you had some really good talks and found out some useful information and found some other people who are facing similar questions and challenges to you. And so my name's Mike Streetley, and I'm chairing this session on principally on climate change, really. It's really good for me to be at a careers day because 35 years ago, I set out in my sister's car to attend a Geological Society careers day and didn't make it. And I'm not going to tell you why I didn't make it, but anyhow, it didn't stop me having a very rewarding and fulfilling career for 35 years in hydrogeology. And if you don't know what hydrogeology is, next time you're looking at a thin section, stop looking at the pretty minerals and look at the gaps in between and wonder what was in those gaps when this rock was in the ground and how did that get there and where's it going? And if you can answer those questions, you're then a hydrogeologist. Anyhow, so this is a session principally about geoscience and climate emergency. And I don't have to rehearse for anyone here how serious the climate emergency is for us now and how serious it's going to be going forward. But this is about what we as geoscientists, or principally you as the future generation of geoscientists, will be able to do to contribute to society's response to that. And I'll leave it to you to make your own judgments as to whether we're on track or not. But I think that earth scientists have a particular perspective on this because we're used to looking at billions of years of Earth history in which the Earth's climate has moved through a whole series of different states, from hothouse to snowball Earth, etc. And really defining and refining our understanding of those conditions is absolutely crucial to being able to accurately predict how the stresses that we are now putting on the climate will, how that will affect the Earth's climate and environments going forward. So I think we've got 4 excellent speakers lined up here who are working in exactly this in different ways. And so you're familiar with the way this is going to work. We'll have 4 speakers give 5 minutes each, and then we'll have some panel questions either in the room or on the Mentimeter. So our 4 speakers are Anna Valencia, Libby Robinson, Charles Fuchs, and Lindsay Fox. So I'll get Anna to come up first and tell you about what she's been up to.
So hello everyone, slightly different. So I'm not a geoscientist, I'm an ecologist. So I'm a marine consultant and I specialize on marine benthic ecology, so the habitats and species that live on the seafloor. And I've been working for a company called Marine Space for around 2 years now. So my career began at university. I knew I wanted to do something in marine science and ecology. So I chose an undergraduate in marine biology and coastal ecology. And I chose a degree with a year in industry because I wanted as much work experience so that once I finished uni, it would help me get a job. So I chose a work experience in Chile at a marine station there. And essentially I worked as a research assistant. I got to assist in field work. So I got to install experiments and monitor experiments in the intertidal zone, as well as I assisted in the laboratory processing samples, also did some imagery analysis and did some data analysis statistics, and it as well got to do some scientific dives. So in my 3rd year, I should say as well, while I was doing my my 6 months in Chile, I was also running my undergraduate research. So I learned a variety of skills while I was doing my work experience, and also got ahead in my undergraduate, in my thesis. So in my 3rd year, I'll just move to the next slide. So then in my 3rd year, I also volunteered at the Marine Biological Association. I really love data, so I wanted to get involved and get more experience with data management. So I got introduced to GIS and just data management and processing. So after I finished uni, it proved a bit difficult to find work, but I did apply for a 3-month paid internship with CFAS, where I continued to develop my statistics using R and GIS, and did some species distribution modeling on sea-pen species, which is a benthic species that you can find across the North Sea. So I learned loads of skills as well through this. But then once I finished this, I moved away from academia and went into the private sector. So I joined Guardline, which is a survey company, and I joined as a marine reporter, environmental reporter. So essentially, I reported on the scientific findings of environmental surveys from offshore. So this will be analysing photographs of the seabed, identifying it for the habitats and the species, and also the laboratory analysis of the grab samples, so the macrofauna, the chemicals such as metals and hydrocarbons, just to get a picture of the baseline of that environment for where the project would be developed. But yeah, after working there, I developed my GIS skills, my statistical skills, report writing. But yes, I wanted a more challenging job. And so I moved over into consultancy, where I got a bigger picture of the project development process for offshore wind farms, aggregates. Got into the environmental impact assessments, so pretty much determining if the project would have a significant impact on the environment, specifically for habitats and benthic species. And yes, I also get involved in research and development projects for nature conservation bodies such as Natural England, and we get to have a part in very influential topics at the moment, such as habitat compensatory, and also looking at climate change. So we did a project on the vulnerability of marine protected areas to climate change. But yeah, it's a very interesting job and career to be in at the moment, and we get to have an influence. But yeah, I put some work examples through academia that was published, but you can also have an influence through the private sector as well, and very influential topics. Yeah.
Great, thanks very much, Anna. And next up, we've got Libby Robinson, who's going to talk about what she's been up to.
Hi, thank you very much. So my name's Libby Robinson. I feel like I've got to apologise in advance. I've seen some really great slides today, and I obviously didn't take the PowerPoint training that we mentioned this morning that every geoscientist needs, so please bear with me. Hopefully my story will be more interesting than my slides may portray. But I'm a principal consultant in a company called Nature Positive. We are part of a larger group called RSK, so we've had a few colleagues come up today already talk about some of the work that RSK does. But I'm within the Nature Positive team. We're a smaller team, maybe 60 people, and I'm in the carbon, climate and sustainability team of that. So the team as a whole looks at a lot of biodiversity issues, but the team that I'm in looks at carbon and sustainability, and how that relates to biodiversity and the wider environment as well. So a bit about my journey. I have a geological background. It's really nice to be stood here. I feel like the GeoSoc's kind of like my home, so it's really nice to be here again. I did Earth and Environmental Science at Lancaster University, feels like way back in the day. And then I've also got a PhD in paleoclimate as well. I go on to the next slide. That probably is a better representation of my journey here. So if I start at the beginning, at school, there was no option to do geology A-level, as I think a lot of people have kind of mentioned, but I knew I liked being outdoors. I knew I liked the environment. I knew I liked being a scientist and kind of figuring out problems. So the A-levels I took were biology, chemistry, and geography. And that got me into Earth and Environmental Science at Lancaster. So I wasn't quite sure on the geology aspect, so I did a dual honours. But it turns out I really liked the Earth aspect. I really liked looking at rocks. So I graduated there in 2010. Had a bit of a career gap, so I was waitressing for a bit, kind of figuring out what job I wanted. But then I ended up working for a company called Neftex, which was in the oil and gas industry. So I started there as a geoscience technical assistant, and then kind of went through the ladder over a series of years there to lead my own team, and then became senior geoscientist. The work there was very much kind of like wireline logging or interpretation of wireline logs, production of gross depositional environment maps, so a lot of paleo environment, thinking about what the world looked like millions of years ago in order to work out basically where to drill for oil and gas. So I kind of focused on source rock geochemistry, and I was a source rock geochemist, geoscientist for a number of years. So it was a really great job. It was 4 years as Neftex, and then we got taken over by a company called Halliburton, which you may have heard of. So I think we had 3 years as that. And then I decided I wanted to diversify, and I didn't quite know what I wanted to do. So rather than maybe start off in a new industry at the bottom rung of the ladder, I decided to do a PhD. I was a bit of a geek, quite liked academia, quite liked research. So I did a PhD at the University of Southampton in paleoclimate, so looking at what the world was like millions of years ago. And my dissertation topic, or my thesis topic, was looking at the mid-Cretaceous, so a really, really hot time of the world's history, and looking at what the ocean chemistry was like at the time and how that can possibly be analogous to today. That's kind of how it got me into my current job. But at the time, I also did an internship with DEFRA as well, which was really valuable, because that's about seeing how the scientific work that we're doing, or the work that we're doing, can be applied in kind of modern day legislation and kind of like modern day relevance. What else can I say about my PhD? It was great. I enjoyed it, but I decided that I didn't want to stay in academia. At the time, so once I was finishing up my PhD, I didn't really know where I wanted to go again, kind of a little bit directionless. But I spoke to a friend who I knew from my undergrad days, that said, do you have any advice? I want to maybe go into environmental consultancy. And she worked for Nature Positive and said, well, actually, we've got a position in our team. So that really shows the power of keeping your networks up and kind of keeping your friendships going and just checking in with people all the time. So now I work for Nature Positive. We do carbon footprinting work, greenhouse gas assessment works for companies. So we do a lot. So for UK projects as well, so environmental impact assessments, we'll work out the greenhouse gas emissions for various projects. We do lots of UK renewable based work, but then also global work as well. So for big mining projects, we've done graphite mines, rural electrification projects in Africa. We've worked out what the greenhouse gas emissions impact might be for those projects. And we're also looking at climate risk as well. So the risk of climate change to companies in the future, and also projects as well in terms of physical climate risk, also the transitional risk as well. So as policies and legislations change in the future, how that might impact businesses. I feel like I'm probably going over time, so I'll leave it there. But if anyone does want to chat about any of this, please feel free, as well as the panel, to come catch me in the breaks.
Thanks for that, Libby. And so Charles Fuchs now from ADAS.
Cool, thank you everyone. So yeah, my name's Charles Fuchs. I am a director of climate adaptation and resilience at a company called ADAS. So ADAS itself is a kind of agricultural environmental consultancy and is part of the wider RSK group of companies that Libby and others work in. My background, I've always really loved kind of geosciences and geography from a really young age. I went into a geography degree at the University of Exeter, and yeah, sort of studied things like quaternary geomorphology, earth system science, glaciology, and things like that. Really fascinating stuff. I did my dissertation looking at the potential limitations of using the Schmidt hammer, which is like a little rock tool to measure glacial or late Holocene age moraines. I guess following my degree, I then wanted to sort of keep in that space. So I sort of developed into what's the more practical side of where that might lead. And I moved into a master's in climate change risk management. That was a really fascinating course. And I moved on to sort of do my dissertation looking at extreme rainfall events in London and how they're changed over time. And yeah, probably frowned upon in this room of people, but I'm also a fellow of the Royal Geographical Society and a chartered geographer. But there's a reason I sort of got to that stage. So yeah, where I started out, I mean, yeah, following finishing my degrees, finding a job was quite difficult. I'd applied for quite a few different places, things like the Met Office, Environment Agency, and just wasn't really getting anywhere. I then did a sort of 3-month internship with the Climate Institute in the USA, and then a very fashionable title of Sustainable Travel Advisor, which essentially was going door to door in Cheltenham, knocking to ask people to travel more sustainably on the bus and cycle and things. So slightly different. When I sort of finished that, I was looking for where I could go next. I knew I wanted to kind of stay in the climate space, but wasn't quite sure where to head. So I was applying for PhDs at the same time as applying for jobs in industry. The PhD at the time I didn't get. I came a close second to someone else who had industry experience, which I felt was quite a strange thing because I'd kind of only been in academia and it's like, didn't realize I need industry to get into carrying on. And then I was also applying for jobs at ADAS and was fortunate to get taken on to their graduate program. So I started that in 2013 and have sort of worked my way up the consultancy ladder over the last few years. Yeah, so my current role now as a director in that team and principal consultant, I'm working with various clients. So I do quite a lot of work with local councils and with government bodies and policy. Last year, I was seconded into DEFRA for 9 months and worked with the climate adaptation team there. I do a lot of work around sort of climate change risk assessments and developing strategies for both adaptation and net zero. So yeah, various projects I've been fortunate enough to work with Libby and others on. And this has been a really sort of great experience to apply the knowledge I know about the climate, how it's changed over many hundreds of thousands of years, and how we can apply that to kind of the real world examples we live in now. So I think going forward, really looking to sort of continue applying that knowledge. I find that, yeah, climate is something that we all play a part in, we can all impact on. And whilst in this country, we can do our very best to get to net zero, whether that's going to happen at a global level is probably a lot more uncertain. So what we do know is we're already suffering from the impacts of climate. And that's really where I see my role going forward is actually, we're going to get more intense heat waves, more floods. So how do we prepare and plan for that? So yeah, that's really sort of where I've got to. And now in my sort of transition stage from, I guess, early career to now moving to mid-career, I'm doing a sort of level 5 apprenticeship in operational management, which is sort of helping me take that next step further. So I'll leave it there. Thank you.
Thanks very much, Charles. And now Lindsay Fox is our fourth panelist.
Yeah. I feel like my presentation is a good metaphor for my career. I'm winging it ever so slightly. So I currently work as a senior climate change mitigation scientist for the UK government in the Department for Energy Security and Net Zero. Now, I'm just one of hundreds of scientists, engineers, analysts that are all working together to try and reach net zero. So the climate science team is there's about 30 people, and then in mitigation, there's just 5 of us. We've got quite a lot of responsibility. So the role of mitigation scientists is to try and make sure that all these new technological solutions that the government want to implement to get to net zero are not actually causing more problems than they solve. So we spend a lot of time looking for where the gaps in evidence are, commissioning research, and trying to make sure that policymakers have as much detailed scientific information available to them as possible so they can hopefully make an informed decision. So most of my projects that I lead on are to do with the atmospheric impacts of the hydrogen economy and sustainability around bioenergy and biofuels. But at the beginning of my career, I did the Masters of Geology program at the University of Plymouth, followed on by a PhD at the University of Leeds. And I'll talk a little bit more about that on the next slide. So yes, I didn't put a great deal of planning into my career. So I always loved geology and earth sciences, so that's kind of what I did for my undergraduate, but I really wasn't set on a career or didn't know what I wanted to do until the last year of the MGEOL program, when I started looking at microfossils. And I did a summer research project with my master's supervisor, Malcolm Hart. I loved that, and I still didn't know what I wanted to do. And he said, oh, you should go and do a PhD with Bridget. So that's Bridget Wade at the time was at the University of Leeds. So I applied, and that's what I did. So another paleoclimate PhD, it was on an interval of rapid climate change during the Miocene. Absolutely fascinating. I loved the first 2 years, the writing up process, not so much. And I got to the end of my PhD and I wasn't sure what I wanted to do with it. And my supervisor said to me, well, you should apply to go on an international ocean discovery expedition. So that's what I did. So very easily swayed by peer pressure, as you can tell. So we almost immediately after I submitted my corrections, we sailed out to the middle of the Indian Ocean and started drilling the sediments in the Bay of Bengal to try and work out the timing of the uplift of the Indian monsoon. And I was all ready to go to Nottingham University and sort of do a postdoc researching these amazing sediments that we collected. Then a friend of mine at the Natural History Museum said, actually, you should come and work for us. So that's what I did. So I initially started on a 2-year project looking at the BP micropaleontology collection. So BP were getting ready to throw out all their old samples, but the NHM rescued it and no one had studied these before. So I started looking at these, got to hurry up, started looking at these microfossils to try and reconstruct sea level. And it was so kind of what tied my research career together was looking at intervals of rapid change in Earth history. And it was while I was there, I kind of realized actually the most rapid interval of climate change in Earth history is the one we're experiencing now. So I shifted my focus to look towards the current and future climate change. And I'll skip over the teaching fellowship because that was just a very short contract. And I eventually became a lecturer in climate change at Kingston University. And I absolutely loved teaching. I loved engaging with the students and having great conversations, but then the pandemic hit and it became a lot less fun sort of teaching to a computer screen in my bedroom. So then the opportunity came up for me, instead of just talking about climate change, to try and do something about it. So that was when I made my shift to the government. And I think that's me out of time.
Great. So can we get all the panelists to come up here and sit along the front here? And while that's happening, we'll get the the Mentimeter warmed up.
It's more than one already.
Yeah,
So there'll be
Yeah.
a question under here as well.
yeah.
It goes in like succession.
Uh,
You also do a
so,
questions in the room and
yeah, okay, great. Okay, thanks everyone. So be thinking about the questions you're going to ask. I'll see if there's some hands in the room in a second, but I'll just first pick up one from the Mentimeter, and it's a fairly common one, I think, and I'll just ask you to go through from this end, Libby first. It's in terms of, do I need an MSc to get a job in your particular area? Do you want to pick that up and pass it along the table?
Yeah, sure. I mean, I don't have an MSc. I would say not necessarily. I mean, I do have a PhD, which is something slightly different, but I went into that not having an MSc. I went into my first job not having an MSc. I think it's often all about your attitude, whether you're proactive, whether you can show whether you're interested in a subject or not. It often does help, especially if it's a very focused MSc in a particular topic that you want to go into. It doesn't hurt, but I don't think it's necessary.
Yeah, so I'd also agree. We have people that come in with degrees, with MScs, with PhDs, and quite often they can start at sort of similar levels because it's then applying that knowledge and application to what we do. I think it's probably far more important to make sure you have something that distinguishes yourself, a bit of industry experience that really makes you stand out a little bit. Because if you imagine when you're kind of put out a job advert and you've got 100 people apply, they've all got a degree, so that's a tick box, then it's kind of what makes them stand apart. And actually, yeah, industry experience I think is really important for sort of trying to get into the sort of consultancy environment.
Yeah, so for entering the civil service, no, not necessarily. So there are lots of different ways you can join. So there's an apprenticeship scheme where you can work 4 days with the civil service, and then 1 day a week you're studying at the university. And it takes you 5 years to get your bachelor's degree, but you've been earning while you're learning the whole time. Another entry route is the fast streamers. So after you go straight from your undergraduate and you spend sort of 3 years of going around all the different departments in government, and you don't earn very much for the first 3 years while you're sort of on these rotations, but once you complete that fast track, you go straight into a senior management role where you're earning like the megabucks. So that's quite a good way to do it. I did not do it any of the sensible ways, as you could see. So yeah, if you want to enter directly as a scientific specialist, you will need an MSc at least, but there are definitely ways you can work your way up.
I'll agree with all the panelists. I myself don't have a master's, or no to some of my colleagues. Yes, I think it's a lot about the work experience you have that will help you get the job, and a lot of it is just learning on the job. I think some of the skills that you require you can't learn during a master's. So.
Right, thanks for that. And thanks, Lindsay, because I see there's a couple of questions specifically about civil service and DEFRA, which I think you've kind of covered with your description there. So hopefully whoever's asked those online or in the room, hopefully that's addressed your concerns there. I mean, I'll just add one more perspective from the hydrogeology front, where I think that is perhaps one of the more applied areas where an MSc would be, so it's not for all subjects that I think you all said that it wasn't necessary, but it's very career specific, I suspect. Shall we have a look around the room and see if anyone's got anyone's questions up there? Yeah.
This is mainly for Anna and Lindsay. I was wondering what the publishing process is like, and also kind of like, yeah, in terms of like getting papers published and so on, and how you can like balance that with other aspects of your life, perhaps including doing, say, a postgraduate degree or an undergrad, even, just from my perspective.
Oh, that's a good question.
Yeah, so I think when you're publishing a paper with other authors involved, you kind of share the workload, so it's easier to balance. And also, like I also showed, you can also publish work in the private industry, which can be really important, influential pieces of work, and then you get paid for that as part of your job.
Yes. So I have a little bit of experience of publishing policy documents and publishing academic papers, and it's two almost completely different processes. With policy, it felt like the workload was shared by a lot of people, a lot more, and it's part of your job, so you're given the time to do it. Whereas when I was a lecturer, I felt I was having to carve out time in between lectures and all the other admin jobs I had to do to write. So it is tricky, and I think having a supportive research environment where you're working that supports you in writing is very important. Yeah.
Right, thanks for that. Yeah, and I'll just make the Geological Society Publishing House is here today, and you know, if you talk to them, you know, content is king, and they certainly, like in my field, the Quarterly Journal of Engineering, Geology and Hydrogeology is quite an applied journal, and they're always on the lookout for interesting work that you're doing. Finding the extra hours after work to write that up is a really valuable thing to share that experience. So please, when you're thinking about your career, do look for opportunities to write things up and try and find the time for that. But it is hard work, I can tell. Yeah, perhaps we've got some questions here about volunteer and internship opportunities. You know, are there many out there in your sector, and how do you get into them? We'll start at Anne. Put you first this time, Anna. You start from there and come back this way.
Yes, I mean, I think like university normally helps. Like they normally have pages where you can have a look. Normally, they have a list. Also just have a look at what other subscriptions you can get. Like I get email subscriptions, the jobs, and I also advertise work experiences for my field. And yeah, I mean, for my internship, I couldn't quite afford going abroad, but I also looked at bursaries and applied for it. And then that could I could then afford to do internships, because I know not everyone's quite fortunate to be able to pay for their own.
So we don't, it's quite difficult to do sort of short-term work experience in DESNZ, because there's a lot of security checks and a lot of highly technical work. So we do get PhD students coming in for 3-month periods to learn a little bit about policy. But yes, we don't have a lot of work experience opportunities in our team.
Yeah, and I think, yeah, for me, I found it quite tricky at the time trying to find those sort of placements, internships to get a bit of experience. And that's probably why I ended up in the US with the Climate Institute for those few months, partly because I wanted to incorporate that sort of element of getting out and traveling a bit as well. Within ADAS, we do take interns, and quite often they are sort of year placements which form part of degrees, but yeah, usually kind of linked with the universities. And I think, yeah, keeping track of what they have on offer is a really good way of finding those.
Yeah, I'd reiterate with that. So in our part of the company, there are internship opportunities. A lot of them are associated with universities. So like Anna was saying, kind of use your university network, investigate what's available. But I would really say be proactive as well. So the internship I got with DEFRA, it was a scheme that I applied for, didn't actually get it. So I then had a look at other funding opportunities, managed to secure a funding opportunity, and then went to DEFRA directly and said, I've got the money, can I do this placement with you? And they said yes. So be proactive. Maybe reach out to people on LinkedIn in a polite way. You know, if there's a company you really want to work for, try and get some sort of connection with them and just talk to them directly. The worst they can say is no.
Okay, thanks very much. How about something else from the room here? Yes,
Hi. I wanted to ask Lindsay a bit more about the kinds of projects you've worked on for DESNZ, and also what are, if any, the challenges of sort of working for the civil service and the government on these kinds of issues?
Have to be careful how I phrase this. Okay, what's not going to get me sacked? Changes in government can be quite challenging, and working with politicians can sometimes be challenging. I think in the first year of me working for the government, we had 3 prime ministers. And I think we're on our 4th Secretary of State. So every minister we get have their own individual ways of how they like to work, how they like to receive information. So you have to learn all these things all over again each time. So that's probably the challenging aspect. But what I love about my job is I get to learn about so much science and so much cool climate science and climate solutions and trying to reach net zero. And just work with really clever people all day, every day, which is really nice. So without going into too much detail, because there is security, confidentiality issues. So the government is very keen on implementing a hydrogen economy. So this is sort of public news. They want hydrogen to be 30% of the energy mix by 2050 or something. But we don't know enough about the environmental impacts of hydrogen in the atmosphere. So it's not a greenhouse gas in itself, but it has a greenhouse warming effect because of how it interacts with other elements in the atmosphere. So we have to be careful about any leakages. So the government funds a program of research with NERC looking at the different sort of environmental factors that hydrogen can have on the atmosphere and the soil interface. So I lead the government side on that, and I meet with the researchers and find out what the latest results are, so I can feed that back to ministers. So hopefully they make the right decisions.
Okay, does anyone want to add anything?
Yeah, I'll
there?
just pick up and I mean, DESNZ and DEFRA and other departments all work on some really exciting projects. They don't have all the expertise in-house, so a lot of the work they do is kind of outsourced, and that's where us as consultants quite often get involved in all sorts of things. So yeah, there's definitely opportunities, whether you're in government or out of government, to have that kind of influence to help support some of the great things that are being done.
Definitely.
Okay, so I've got a question online here for probably mainly Charles and Libby here. So Libby first, then Charles. It's about getting into a career in climate risk assessment. Do you want to just say a bit about that?
Yeah, sure. So climate risk assessment, so the risk of climate change to businesses is becoming a really big topic at the moment. So there's increasingly work in this sphere. I think in terms of getting into jobs or getting your career in kind of climate change risk, geology is a really great starting point, because as you mentioned in the intro, Mike, like you just have a really broad picture of how the world works when you study geology. You understand all of the different systems, how they interact on a big scale, but you also know you understand the detail as well. And all of that thinking is really useful when looking at the broad picture of how climate change is going to impact on businesses, organizations, on projects. So I think geology is a really great subject to learn to go into that.
Yeah. And I think it's very much a growing market at the moment. Policy is a key lever towards that. And yeah, having our net zero target obviously means lots of companies need to be doing something, and that involves having to carbon footprint to develop strategies, etc. In terms of risk assessment, there's more and more kind of mandatory reporting that's coming out. So the Task Force on Climate Related Disclosures that's now applicable to all large companies in the UK means there's lots of organizations now actually having to consider their climate risk as well as their sort of carbon footprint. So yeah, there's lots of sort of opportunities there to get involved in it.
Is that anything from you guys? Okay, another question in the room somewhere? Anyone got anything here? Okay. We're allowed to.
This one is more of a question about, I guess, maybe job satisfaction and that kind of thing. Like when, you know, you as a consultant sort of provide your clients with information, whether it's like a environmental impact or something like that. I guess it's more of it's how often do you see follow through and impact, and like, because I guess they don't, at the end of the day, they don't have to take the advice. I don't know, like, how does it work as someone who knows so much about the climate is giving that advice? How does it feel to kind of be in that job?
Start with you again, Libby, and then move across there.
I'm smiling a little bit because it's a good question. There's a lot of talk about whether the work you do is just tick boxy or whether it's making an impact. And I think maybe it's a bit from column A, a bit from column B. At the end of the day, a lot of people, a lot of companies are doing this because they are required to. And a lot of the time, the recommendations we give, they do have to adhere to and they do have to adopt. So there is that. But I find it very satisfying. A lot of the companies we work with are doing it because they think it's for the good of their company, or for the, you know, for ethical reasons, for moral reasons. They're recognizing that if they lower their greenhouse gas emissions, that's better for them as a company as well. So not just for ethical reasons. So that it's like a bit from one side, a bit from the other, but there are a lot of people out there doing things for the good of the climate and, you know, the country, because they think it's the right thing to do.
Point out we're drawing to a close, so if we go through quite quickly.
Yeah.
In the last few
So yeah, there's lots of really interesting projects that we work on and can submit to clients, to government, etc. And then they don't always go to where we'd like to see them. Sometimes, priorities change, governments change. I mean, just COVID and things like that have changed priorities for people. So whilst sustainability might be on the agenda one day, another it's kind of cost of living, survivability. So yeah, not everything that we do might get to the very end point we want it to, but there are those opportunities for those projects to have that real impact, and some of them do go all the way, and you see that real change influencing through future policy.
Yeah, so job satisfaction depends on how good the minister is that you have at the time. It was a bit of a dark 8 weeks while we had Jacob Rees-Mogg as our Secretary of State. But I think what is great about the research the government funds and works on is that it's all publicly available. So whether the ministers use it or not, what we find out about anaerobic digestion technology, biofuels, hydrogen technology, that all becomes publicly available. So, you know, even if the minister at the time decides they don't want to act on this information, it's there for everybody to make their own decisions and learn from it.
Probably less climate change, but as a marine consultant, if we determine that a project will have a significant impact, that is something the client has to take seriously and propose additional mitigation to then reverse it back to non-significant. So in that sense, it's taken seriously.
Good, thanks. And good question, because I've got to wrap up now, and I've got one slide which relates to some research I did for the hydrogeology group of the JOLSOC last year into what was the challenges for people to get into careers in hydrogeology. So I did an online survey of hydrogeologists, and I got a couple of hundred hydrogeologists to reply. And one of the questions I asked was, would you recommend a career in hydrogeology? And about 90% said yes, but it was I asked them to put, you know, some words down as to why. And this is a word cloud of what people liked about their job. And I suspect this isn't unique to hydrogeology. I suspect that this would, if you ask the question about the jobs that these guys are in, this would be exactly what you'd see. You know, really interesting work, wide range, you know, important for society, challenging, great group of people to work with, really rewarding careers. So, you know, I just thought I'd put that up there and say, you know, go for it. There's a lot of good jobs to be had out there. And a lot of the companies are crying out for really good geoscientists. So I think that's a good point to stop the session. Thanks very much.
Hello, everyone. We're going to begin another session now, so if you could remain seated. Thanks.
Hello and welcome. My name is Kate. I'm Membership Services Officer at the Geological Society. I'm going to provide a brief introduction into membership at GeoSoc, and then I'll let my colleague Eleanor talk a bit more about chartership with us. Founded in 1807, we are the oldest geological society in the world, and today we are world-leading communicator of earth science. The Society is the UK professional body for earth science and has worldwide membership of 12,000. Our members cover spectrum of geoscience professions from industry and consultancy to education and public sector. Our aims are to improve knowledge and understanding of earth, to promote earth science education and awareness, and to promote professional excellence and ethical standards in the work of earth scientists for the public good. So, the benefits. We have a wide range of benefits to support our members through every stage of their career. So one of them is access to resources and publications like our journals, books, and library. You also have access, as a member, you also have access to this beautiful building. Sorry, went to the next slide on my screen. So we can connect with our network of scientists. We've got regional groups and specialist groups, and so everyone can find like-minded people to network with. That includes access to events and conferences, and for students, the access to our online events is free of charge, so it's good to sign up today. We've got lots of professional development opportunities, including opportunity to become chartered. You can be a chartered geologist, chartered scientist, or European geologist. Eleanor will talk about it a bit more in a minute. And finally, advocacy and impact on in earth science. So that's including supporting education, responding to government consultants, and facilitating knowledge exchange across community. So if you haven't talked to us yet, we have a booth at the lower library. Please come talk to us about membership and student membership. We are happy to sign you up today.
Thanks very much, Kate. So as she mentioned, you're also able to look at chartership. If you've not heard of the word chartership before, I'd just like to introduce you to the concept and think about why it's something you might want to keep your eye on as you graduate and start the early part of your career. So as Kate mentioned, we award both chartered geologist and chartered scientist here at the Society. So this is the way I think about it. You've completed your higher education, so whether undergraduate or postgraduate, but chartership is an important professional milestone. I think as one of our panelists mentioned before, whilst they might have a master's or maybe don't have a master's, there's a lot of experience that you gain as you go along in your workplace that is not stuff that you covered during your educational time. So that educational background provides you with the technical knowledge of your specialist area, or you might even be at the forefront of that science if you've perhaps done a PhD or worked within academia. But if you're chartered, this provides you with a formal qualification that validates your competence at applying your knowledge in a practicing professional capacity. So you might have a good academic grounding in one particular area, but chances are your professional role has either evolved into a very specialist niche, or perhaps it's an area of expertise where you've got a lot of crossover with other disciplines. And a whole degree doesn't probably exist for that. So chartership provides a way to evidence that expertise now that it's evolved in your workplace. So this slide just sets out some of the things that having chartership shows the skills that you have. So it's not just about your level of specialist geoscience or scientific knowledge. It's also about having some key strengths that being chartered can demonstrate to others. So it's also about your presentation skills, your appreciation of ethical behaviours and sustainability, and implementing rigorous health and safety, for example. In many areas of geoscience, it's also a stepping stone to becoming a recognised competent person, perhaps in the minerals sector, or further qualification in your specialist area. So, for example, in ground engineering, you've got ROGEP, or you might want to become a silk practitioner if you're working in contaminated land. So aside from the evidence for your credentials, what are the benefits to becoming chartered? Increased pay and recognition by your employer is a very tangible benefit, and it's a way to make yourself stand apart from the crowd. I know that many employers support that development through to chartership, and is a benefit for them as well in having accredited professionals in their workplace. But what about the other benefits? Some of these are harder to quantify, and I've listed a few of them here. So from a personal point of view, I achieved my chartered geologist status in 2020 as a hydrogeologist before coming here. I found that putting together my application and achieving chartership gave me the chance to reflect on what I'd accomplished, what I was good at, identifying where I could continue to develop my skills, both technical and professional. So chartered status is highly relevant to anyone across the various geosciences. So geology, geophysics, engineering, hydrogeology, oceanography, geochemistry, geohazards, quarrying, and all sorts of other fields. Whilst we've got the term geologist in the name for the society and our chartered geologist option, any aspect under the umbrella term of geoscience or earth sciences is incorporated. GeolSoc recognises and promotes the ongoing development and expansion of what constitutes geosciences. So don't think that chartership with GeolSoc is not for you just because you don't consider yourself an out-and-out geologist brandishing a rock hammer and a hand lens to peer at rocks. In terms of eligibility, you do firstly need to be a fellow of the society. So we do recommend if you start today with your student membership, you can develop your sort of membership pathway through your early career and towards chartership. And this is accessible to anybody who has a degree in geoscience or related subject, being a fellow, or is employed in a role where geology is a key component. You also then need to be able to meet our chartership competency criteria. That's the key thing that you'll be looking to demonstrate. So whilst we don't specify a number of years of experience, I would say typically it's 5 to 6 years post-master's level. And for those who don't have a master's level qualification, we do have an alternative route where you can provide a master's equivalence report. And as we've covered before, you're gaining a lot of experience through your career that will have covered that master's equivalence. So to become chartered, there's an online application process with a number of documents to include. We have 4 deadlines per year at GeolSoc, and this ties into our council meeting schedule so that you're formally elected as a chartered fellow. There's about a 3-month window from submitting your application and all the documents being reviewed. We have a peer review process with 2 chartership assessors. For example, Mike, who was chairing the previous session, and Ruth are 2 of our assessors. So they're real humans, they're not scary people. They're chartered fellows of the society themselves. So they're either chartered geologist or chartered scientist, and they undertake this role for us as volunteers. So it might seem a long way off if you're perhaps still studying at the moment and you think, oh goodness, that's years away. There are a few things you can do to start your chartership journey as soon as you've graduated. So once you're in the workplace, I would collate a portfolio of your work over time. So just keep a record of the projects you're involved in and have a look at those chartership criteria so that you can have a look and see what you would be able to demonstrate your competency at using those examples in your portfolio. We'd also recommend starting recording your CPD. So not just a list of what projects you've been working on. It's always about recording your learning points and reflecting on experiences. So we'd really recommend doing this as soon as you leave higher education. It really allows you to take charge of your own career progression and provide some structure as you move through your early career towards chartership. And you might have great development support from your employer. Perhaps if you stay with one employer for a long time, but if you move jobs or change career path within geosciences, it might feel a bit disjointed. So having a CPD plan from the get-go means taking charge and being proactive with it. And lastly, get a mentor at each career stage. So someone who has a bit more experience than you, who can provide some steer and anticipate what kind of experience might benefit you or what pitfalls to avoid. So they can help you with the chartership process if they're also chartered themselves. But I think, as we've heard from some of the speakers before, just leaning on people who have got more experience than you can gain these mentors by engaging with your regional group or specialist groups. And then they'll be in a great position to help you judge whether you're eligible and ready to apply for chartership in due course. So I just wanted to provide a brief introduction and not go through the sort of nuts and bolts details of applying, but it's just to get you thinking about where chartership might fit into your career in a few years' time. So if we've got any questions, I'm happy to take a question if we've got time. Got 2 minutes. Oh, sorry. Or questions about membership as well. Or come and find us. We've still got some Kit Kats left.
For the master's qualification, I'm in an integrated master's program. Would that be considered as equivalent to a master's qualification, or would I have to do a PhD additionally to that?
No. So the master's level, it's sort of as defined by the UK Education Authority in terms of being level 7. So if you go on the .gov page, everything that comes under level 7 as the different variants of a master's level, they're all eligible. Thank you very much. This one up here.
Other than projects, what things are worth putting on the CPD?
So we've got a mind map. If you go on our CPD section of our webpage, we've got this big spider diagram with all the different kind of categories. So it's not just about the technical scientific content of your project, it's about other aspects of being a practicing professional. So for example, sort of a lot of the focus is on the job training, so things that you've learned as you've gone along, perhaps interactions with clients, meetings that you've had, lessons learned if things haven't gone perfectly to plan. That's all part of CPD. It's about your whole kind of professional experiential learning, not just the actual rocks that you might be talking about.
How does this the Geological Society accreditation thing we're talking about compared to like the Geological Society accreditation like within your actual degree? Like, some degrees have like, if they're accredited by the Geological Society, is that a different thing or is that the same thing?
Yeah, that's a different thing. So having an accredited degree is helpful for you applying towards chartership. They're not on an equal level, if you see what I mean. So if you've got an accredited degree, that's great. It means that when we receive your application, it's a much quicker process for us to sort of review your eligibility before your application can go forward to the assessors for review.
Thanks.
Super. Thanks very much. I think the next session we're handing over to Nat and the planetary session.
No, any order you like, is fine. You'll be standing up first, but it doesn't matter. You can wing it around. I'm only talking for a couple of minutes and then I'm handing over, so it's all good. Okay, I hope you're all in the right place. This is the planetary science section. Okay, welcome back, everyone. Thank you so much for staying and joining us for the penultimate panel session of the day. There's one more after us, but there is a break after us. So thank you for staying. I'm Natasha Stephen. I'm the Director of Science and Engagement here at the Geological Society of London, but I'm also an honorary lecturer at Imperial College London, and that's because I'm also a planetary geoscientist, so hopefully very well suited to being part of this group here today. I did my undergraduate at Royal Holloway, University of London, and like a lot of you that I've already spoken to today, I did a integrated master's, so I did the master's without graduating, and I did a project in Icelandic volcanology. I really wanted to do volcanoes. And it was great fun and I loved it, and I got to do field work, and then I got to do a lot of geochem in the lab, which I didn't love quite so much, but I had a really good time. But at the end of it, I decided that I really liked volcanoes, but everyone was studying Iceland, everyone was studying Hawaii, everyone was studying Italy. Where were people not really studying volcanoes that I could go and do something a little bit different? And I was one of those people that always wanted to be a geologist from a very, very young age, collecting rocks and fossils on the beach and driving my parents mad with the amount of things I'd bring home off a holiday. But the other thing that I always really wanted to do was be an astronaut. So when I was finishing my master's, somebody came and gave a talk on planetary geology, and I realized I could do geology in space, not literally, of course, but the geology exists everywhere around us. And I discovered that there were volcanoes out there in the solar system. So actually I could go and I could study those, which no one else was studying at the time. So I did my PhD at Imperial College London, focusing on the geology of Mars and linking up physical samples to satellite and rover observations. And I kind of haven't stopped since then. But we're here to talk about planetary science. So what is it? Well, we are all very biased on this panel, of course, but technically all of geology could be planetary science, right? Because the Earth is technically a planet. So when we talk about geosciences, we can widen that out to the whole of the solar system. Not just the Earth, but the other planets around us, the moons, the asteroids, the comets, all those other worlds that we're only beginning really to start to explore around us. It is a little bit more challenging, of course, to arrange field trips if you want to go out and explore the solar system. So you do kind of have to rely on a lot of those things coming to you, or relying on space exploration missions. We've got some really fantastic missions going on at the moment that have just come back, that are just going, that are in the works in the future. And a lot of the digital tools that you've heard about already today have long been used in planetary science, because that's one of the only ways that we can explore some of these worlds. The rovers that are roaming around on the surface of the moon and Mars, satellites that are mapping other worlds and taking images of places that we couldn't get to in a human lifetime. It's a really, really exciting time to be a planetary scientist. And that's because we ask the really big questions. Geologists were used to talking about geological time and how the Earth evolved, but actually we go one step further. How did the solar system form? When did it form? Why are all the planets different? What's going on? How have they evolved through time? And why are we the only place that we found life yet? Could life be out there somewhere else in the solar system, or even further beyond in the universe? Now, of course, we can't answer all those questions here today, nor would we try to do so in the panel. So please don't ask everybody if they have found evidence of life. But we do have some excellent speakers here from different realms of Earth and planetary sciences who are going to be telling you a little bit about who they are, how they got to where they are today. And then we're going to open up the room to questions for you guys. So without any further ado, I'm going to introduce people and let them come. Same format as before, a few minutes of an introduction to each of them, and then we'll open up to the room. So we have Francis Butcher from the University of Sheffield. We have Alessandro Novellino from the British Geological Survey, and we have Helena Bates from the Natural History Museum. but that's enough from me. Francis, I'm going to hand it over to you.
Okay, hello everyone. I'm Frances Butcher and I'm from the University of Sheffield, and my job title is a research fellow, which basically means that I spend my days doing research. So I'm in the middle of a 3-year project currently looking at ice on Mars. So newsflash, there's ice on Mars. If you didn't know, here it is. This is the polar cap of Mars, and it's got the 2 polar caps of Mars actually have about the same amount of ice in them as the Greenland ice sheet on Earth. So there's actually a lot of ice on Mars. And so I actually came to this as a glaciologist. So I actually did a geography degree and became really interested in glacial processes, then realized there were glaciers on Mars, and I was totally sold because I was a space nerd as well as a kid. So the way I study this is with remote sensing techniques. So using satellite images, 3D data, much of which from Mars is better than what we've got for Earth. It makes Earth people quite jealous. So we've got 25 centimeter images for Mars, 1 meter elevation models. We've got lots and lots of data to study with to understand processes occurring on this planet and feeding into interesting questions about future exploration of the planet. But I do also keep one foot on Earth. You know, we can't be going to understand other planets without first understanding our own. And it is the fundamentals of our experience of Earth is what helps us to learn about other planets as well. So I mix and match between Earth and Mars, but Mars was my fundamental passion, I think. So how did I get here? Well, I want to emphasize that there is no one route into planetary science, and most people do not start out as a planetary scientist. So I actually did a bachelor's in geography in Cambridge back in, gosh, when was that? 2012. It's quite a long time ago now. And that was obviously Earth focused. And I specifically chose to do geography because I wanted to focus on glacial processes, but equally many of my colleagues came through a geological path. So that was Earth focused, but I chose to do my dissertation on glacial processes on Mars. And I actually went to do a summer project at the Open University to work on that, which is where I then ended up doing my PhD. So I went straight from my bachelor's into a PhD in planetary science, asking questions about whether glaciers on Mars produced meltwater in the past. I then had a decision to make. Do I continue on this Mars path, or do I do a bit of Earth? And I actually decided, you know what, I'm going to learn a bit more about Earth so that I can then translate this back to Mars again. So I actually went up to Sheffield then to work on an EU-funded project looking at the Scandinavian ice sheet here on Earth. So I used the techniques I'd learned applying to planets in my PhD to come and answer some pressing questions about past ice ages on the Earth. And then I've stayed there and built up kind of lots of collaboration with my Earth-focused colleagues to think about human exploration in future of ice deposits on Mars, because ice deposits are most likely where human missions will go because we need the water that's in them for resources, but also because there's great science to do. And so there's all sorts of techniques that you can do in this field. So my focus is on remote sensing, but I also do numerical modeling. Lots of people do lots of field work. Obviously that paused with COVID, but it's kicking off again to do terrestrial analog studies. You can do lab experiments. And also I also work on developing future missions. So I was on a team last year looking at a potential new mission to go and explore ice on Mars towards the end of this decade or early the next decade. So all of this feeding into future exploration of the red planet. So it's an exciting field to be in. I'd be very happy to answer any questions that you have about this, and I'll leave it there for now. Thank you.
Thanks, Francis. I'm only back up for a second because I'm here just to introduce Alessandra to come and be our next intro.
Hi, everyone. I'm Alessandro. I work at in the Earth observation team at the British Geological Survey. In particular, we use satellite data to model, monitor natural hazards across the Earth. So we are the British Geological Survey, but we work a lot also overseas. And I want to be very quick. So I don't know if it's touch screen. No. So I studied in Italy, southern Italy, Naples, I did my bachelor, master, and PhD there. If I have to be honest, everything I did there was useful on a theoretical point of view, but was useless on the practical side. So, but that of course is my personal experience. Consider, for example, most of the stuff I do now is working with coding, looking at satellite data, GIS, which I think they are probably something that should be almost mandatory for new students, but I did nothing. I started doing something during my PhD in Naples, but still, I was somehow lucky enough because I was essentially learning on the job during the PhD. And then after that, it was enough for me. I decided, okay, I need to move on, change country. So I then moved to Nottingham and I started working on a spin-off company, TerraMotion Limited, of the University of Nottingham, where I started to apply the technique I learned during the PhD called INSAR. So essentially it's not a fancy image, but essentially we use satellite data at orbiting 800 kilometers from the surface to measure millimetric motion on the ground. And I was lucky. I was lucky because I think we are now in the golden age of satellite data. So there is a lot of data as never before, and which is acquired regularly all over the earth. And then, after a year and a half, essentially, there was this position at the BGS, the British Geological Survey. I applied, I didn't get it. And after 3 months, I don't know why, never asked. Essentially, they re-advertised that I get the position, and I got it. So I don't know. But I'm happy to live with this mystery. How I did get in earth science, don't laugh, please. But essentially, there is this movie from the 90s, Armageddon. So it was so cool. I thought if you are earth scientists, essentially, I would be one of them. On the other side, for example, when I started studying in Naples, essentially, everything they teach me was all about, okay, you are a geologist, so the only things you need to do is recognizing rock. But actually, it's just the beginning. I mean, it's they never gave me that long-term or wider let's say thinking, like why we're doing this, what's the impact, which I think on this side BGS is quite another level essentially. So that's it. Thank you.
Fantastic, thank you. And finally, our last introduction before we hand the room over to you guys, I'm going to ask Kelly to come and join us.
I don't actually remember what I put on my slides. So my name is Helena. I'm a postdoctoral researcher at the Natural History Museum. And my area of focus is in meteorites and asteroids. So I'm kind of interested in the fundamental questions that we can answer using meteorites. So meteorites are essentially rocks from space. And in many cases, they represent kind of time capsules from the beginning of the solar system. And I'm interested in kind of picking apart their history, looking at their composition, particularly with respect to water. So I'm very interested in water in the solar system. And if you want to ask me if I found life in meteorites, I haven't, but I believe that there's probably life in the solar system, but we can chat about that later. So I did an integrated master's, much like a lot of people in the field have done at Imperial. I did geophysics. So there are the odd planetary science degrees, streams out there now, but they're not very common. And one of the things is that to get into planetary science, you can come from many, many different backgrounds. So I know people who've come from maths, from chemistry, from biology, from materials science, from geography. So it's a very, very broad subject. So I did that for 4 years. I actually started doing geology and geophysics, but probably unlike all of you, I hated being outside. So I switched to geophysics because I didn't like field work, which is unusual for a geologist, I know. And I did my master's project looking at the paleomagnetism in a carbonaceous chondrite. Carbonaceous chondrite is a type of very primitive meteorite. And then I also did an internship during that at the Natural History Museum, where I worked with the meteorite collection there. And then I did my PhD at the Natural History Museum. So Natural History Museum is a bit weird. We have to, it's not an educational institution. They can't award degrees, so you have to be linked with the university. So I was linked with Oxford University, but you linked with lots of links with Imperial, because it's just down the road. I've just put loads of photos of things I do. I do a lot of outreach, being based at the museum. I do a lot of media stuff as well, because museum has got quite a lot of kind of ties with recent exciting missions and meteorites that have fallen. And then I spend a lot of time in the lab, so I'm a lab-based person. So yeah, my timeline, I did MSci Geophysics, as I said. I did my Planeth internship, then I did my PhD, got it in physics. Don't know how I got away with that, but I did. Then I spent a stint as interim meteorite curator at the Natural History Museum, which I like to describe as a nightmare and a joy. It was an experience, because 2 months into the job, there was a meteorite fall in the UK called Winchcombe, which was the first meteorite to fall in the UK for 30 years. And I was responsible for it, and I did not know what I was doing. So we all learnt together, I think it's fair to say. And this is a picture of me on the top left of me receiving the Winchcombe meteorite into the meteorite collection in the middle of lockdown. On the bottom left, we extracted the driveway that the meteorite fell on. That's now just outside my office. And then, so I did that for a year, and then I moved back into research, and I've been basically doing research since then. Like I said, I spent a lot of time in the lab. I'm a destructive sampler, so I get given pieces of meteorite, and then I grind them up, and I vaporize them, heat them up, to basically look at what they're made of. I spend a lot of time traveling. I do a lot of travel, so I'm very lucky to be able to travel to the US quite a lot. I've done quite a lot of work in Japan as well. This at the top left, that's me in an underground lab in Zurich. And then this at the bottom is me at the Diamond Light Source in Didcot, which doesn't sound very exotic, but I promise you it's the coolest place ever. So yeah, that's kind of it. Happy to chat about space and how to do it, I guess.
Thank you. So hopefully you'll agree that we're all just a little bit different up here. And now that we're done with all of the introductions, we're going to start taking your questions. So as before, we're going to open up to the room. There's going to be some roaming mics coming around. So if you've got a question, please shoot your hand up and wait until you've got a mic so that everybody can hear you, not just in the room, but for our audience online. And we'll go to Mentimeter questions as well. Feel free to introduce yourself and where you're studying. If you want to at the beginning of your question, you can stand up, sit down. It's entirely up to you. And our mic has already gone to someone who was very enthusiastic. So I'm going to go straight there in the middle.
I really want to go into space exploration, specifically like exploring the geology of the solar system. So I'm currently studying a geology degree at Portsmouth, and I kind of stuck on what I need to do next. So yeah, what would you suggest I do next?
Who wants to take that one to start? I'm going to come to each of you in turn.
So I can only really talk about the academic pathway. So even when doing sort of space mission stuff, a lot of it does come from the academic pathway. So I recommend that you do a master's if you can, and then a PhD if you can, if you're interested in that. There are other options. You can go and work in, say, there are some couple of companies, especially out near Harwell, I think, which do a lot of work with satellites, which sounds really interesting. But yeah, so I recommend going down that path of doing research. I know that quite a lot of undergraduate degrees don't necessarily have much planetary in them. So doing an internship, like, for example, if you're interested in meteorites, the Planeth thing that I did is funded by the Royal Astronomical Society, 6-week paid internship. And that I recommend as well. And then, yeah, just reaching out to researchers. We're quite a small planetary science community in the UK, so we tend to we can introduce you to people and things like that. So
absolutely. Francis?
I would really emphasize reach out and talk to people. Like we are, as Helly said, we're a small community. You can look people. I'm sorry, I can't see you behind someone else. So get in touch with people and say, I'm really interested in this. Can I come and see what you do for a day? I think there's someone in this room who did that to me as an undergraduate and is now doing a PhD, for example. So I can't overemphasize the importance of making connections like that. Equally, there's actually a meeting that happens occasionally in the UK called the UK Planetary Forum Early Career Meeting. And that's a really welcoming meeting. Probably the most senior presentations you would see there would be from PhD students. And there's quite a lot of undergraduate and master students sometimes come to that. So that would be a really nice place to meet people. It's quite a friendly environment.
And you can join that, the thing that runs that, the UK Planetary Forum, you can join that, you just send them an email and you get put on an email list, and they will often email out opportunities as well.
And you can go to that without having something to present. You can just go for interest as well.
The next one's been announced. It's in London next year.
Oh, is it? Okay,
Yeah.
good to know.
Alessandro?
I don't have the planetary experience there. I think so. My probably is more general suggestion is like probably even in general talk about space and remote sensing is don't think like straightforward, like, no, I need to go this direction. Sometimes opportunity just comes along. So you might start doing something and then like me, I mean, I was, for example, during my PhD doing something specific on Earth observation. And since I joined BGS, they give me also the time to build other skills. And overall, I would say probably all Earth science, I think coding and GIS are, we start hiring, for example, some people at BGS, they didn't have any Earth observation experience, but they have the coding one.
Yeah, I think that's a really important thing. Those transferable skills that you learn in most undergraduate programs can be applied to all of the areas that you've heard about today and all the ones that we don't get the time to speak about today. And planetary science is one of those, as Helly said, you know, it's kind of this bucket that has people from every background. It's not just a true geology program. People come in from everywhere. So yeah, there's lots of good opportunities. And James Darling in Portsmouth is a really good planetary person. So good. Okay, fantastic. Any other questions in the room? Oh, yep, over here. It's a very right in the middle. Yep.
Yeah, I'm currently doing my integrated masters in planetary seismology, and I was just wondering what sort of career options that are out there for either graduate roles or further on, because I'm not sure if I want to stay in academics. So I'm just seeing what's out there.
Let's go to the BGS first on that one, because you're the non-academic person on the panel.
So I would say, again, talking about Earth observation. While, for example, probably 20 years ago, academia was one of probably research in general was, let's say, probably one of the main, let's say, career path. I think now it's more like over the last 10, 20 years, you have development. I mean, all the science has been proved, validated. So some of these techniques developed in academia now have been translated to industry. So there are now entire industry based or spin-off based on satellite data. So there are, both, let's say, roads. And I think also the other things is, while, for example, until 10 years ago, some of these, there were fewer satellites. And most importantly, now the data is freely available. So there is a huge new world of opportunities. For me, I would say it's not just research, academia. There are also like industries, small companies, spin-off. I started in one of them. So it's more about the scale for me.
Yeah, I'm going to bring in a couple of our online questions that are really relevant to this and then open it up to you too as well, because I think it's a really interesting topic there. So a few people online are really interested about opportunities to get into planetary science without necessarily the focus in academia or even going to do a PhD. So you've got 4 people on the panel in front of you that all did do PhDs, but that's not the only way to get into planetary science. There's spin-out companies, satellite data. There's a lot of space-based technology going on at the moment in both the engineering and on the science side, which is a really good way to get into it. So I wondered if anyone wanted to comment on some of those aspects based on your experience and colleagues.
Yeah, I can have a stab. Obviously, I'm in academia, but I've seen other people. There's we're in a new era now of space exploration in which commercial space exploration is becoming a thing. SpaceX being an example. And for example, the Artemis program, which is a joint NASA-ESA thing, is sending commercial payloads to the moon. So I work with somebody, or I used to work with someone in academia who was working with a company to build a sensor that was going to go to the moon. So there's lots of ties between industry and academia in this sense, but there are obviously people working purely in industry on building things to go to space. And that's going to become, that's not going to stop. That's just going to get more and more the case. So looking at companies in the UK or even abroad if that's of interest to you, who are working on space technologies. They still need people who know about the fundamental science working with them to do that. European Space Agency is also an interesting thing to look at. They have a young graduate trainee program where you get to go and work on their missions. And that is quite focused on instrumentation and data as opposed to the science analysis of that data. So that's maybe something to go and look at.
Yeah, I mean, I would basically just agree with what the other two have said. The UK, I think, has a real specialism at the moment at building space instrumentation, particularly with satellites, but also for more deep space exploration as well. We've got brilliant, like quite large engineering companies and then some smaller boutique ones which do kind of satellite work and stuff. So there definitely is scope for doing that as well within industry.
Cool, thank you. Are there any more questions in the room, or should I do another one online quickly? I'm going to go to another one online, but if you have got a question, put your hand up and we'll make sure we've got a mic come to you ready. So the next one is a related subject. What kind of skills do geologists bring to space science industry and research? Is it petrology? Is it GIS? Is it outreach? We've heard a little bit about the remote sensing and the satellite data, but people are asking what kind of online skills can they go and find and train themselves? You know, we're living in a world post-pandemic where there's a lot of information out there and we can always upskill ourselves. So what can people get involved in that might be a little bit outside of the ordinary?
You mentioned online there, but online and just general experience.
In general, yeah, everything.
So I've forgotten the question.
What skills do we as planetary scientists bring to the table? It's not just our very narrow niche of research, it's much broader, those transferable skills.
I'd say it's in terms of skills, it's a hugely diverse field. So I work with physicists, mathematicians, field geologists, people who run models, people who work in the lab, like basically any skill you can think of, you can probably throw at this field. And in a way, you have to be quite creative because we're faced with really big questions. And while our data is amazing, we have to be quite industrious with it because, you know, you might have one mission every 10 years and you have to get the most out of that. So I would say focusing on the skills that you're passionate about, be that field or technical or whatever, but really focusing on adaptability. Like if a new question came along, would you be confident to go and learn the new technique that might be applicable to that? Really training yourself to be able to latch on to new things and learn them quickly is a good skill to learn. Because, you know, I'm using ArcGIS right now, but in 10 years time, the technology is going to have moved on. I'm going to have to start learning that, you know, so I'm currently teaching myself Google Earth Engine, for example, just for fun, because I'm weird. But that sort of thing is really important, I think.
Yeah. I mean, so I think both of you guys do a lot of remote sensing work. I don't do any. So like Francis was saying, you can basically come at this field from any direction. So I come from a lab-based background and a sort of coding background as well. So whatever skills you have, there will be something that you can apply your skills to, I think. But yeah, I know a lot of previous panels have emphasized this. Coding is a great skill to have if you've got it. A lot of sort of people who are currently in the field don't, so you will stand out if you have coding experience.
I would say, for example, even in BGS, we supervise PhD students across UK university. And I would say some of the probably things we use in our day-to-day work, you don't find on courses, on UK courses, like Google Earth Engine, for example. It might be silly to say, but for example, I went on YouTube and you find so many tutorial, step-by-step guide. And this is also with Python or this coding, MATLAB. So I think there are things you can learn, of course, going to university, but other skills that you can learn by yourself, and sometimes are very specific. That is the only way to.
I know there's been a lot of emphasis on coding, and I totally agree that it's really helpful. But if you're sitting here thinking I absolutely hate coding, please don't worry.
We all hate coding.
Like, you can do this without, like,
it's a tool.
You can learn to do it. Obviously, everyone in this room will be capable of learning. But if you really are worried that that's going to be a barrier,
Don't worry.
There are other ways that you can do
Promise.
this.
Do not worry about it.
It's true. There's lots of lab-based ways as well. So Helena talked about the fact that she's a lab-based scientist and she's a destructive person, so she destroys her samples. I'm the other end of the spectrum. I love my rocks, but I don't want to destroy them. So I use
much of them. It's small amounts.
enough of them. Enough of them. You can't just go and get more. It's
That's true.
like
That
up
is
a
true.
mountain and getting more samples with space stuff. So there are lots of non-destructive techniques as well. So we use a lot of techniques that you see that were developed for medical science. So CT scanning, X-rays, we use all of that for rocks now. So you can create these 3-dimensional or 2-dimensional digital models, chemical maps. You can build up fully virtual versions of your samples so that you don't have to destroy them. And there's a lot of work and a lot of opportunity there in sort of developing those tools in like the machine learning side of things, but also just actually running the data. We still need people to work with the physical samples, to play with them, to work out what they're made of, how they formed, and all of that can be done in some of the more traditional methods. So if you love the digital age, planetary science is the place for you. But if you don't and you want to do some of the more analog stuff, that still all needs to happen as well. We have lots of novel ways to combine all of those things. So yeah, absolutely don't be scared of the coding and the digital. It's not all just about that. I have a really big, tough question I'm going to ask everyone, and it's from online. So it's why is exploring planetary materials or planetary science more general? I'm going to make it more general, including Earth observation, because Earth is a planet. Why is it useful for humanity at the moment in the midst of a climate crisis, ecological collapse?
I can go for this one.
Go on, Francis.
I've practiced this enough. Why do we care about what my entire career is based on? So there are several answers to this. However, an important one is that when we're exploring planets, we're pushing the realms of what we can do. So we're developing technologies to explore space that can then be used on Earth for the benefit of humans. There are a couple of examples of this. There's currently a spacecraft on the way to Mercury called Bepi Colombo. Now, obviously, humans are never going to go and live on Mercury. However, there's a thermal blanket, I think, on that spacecraft that was used to develop, I hope I'm not making this up, used to develop personal protective equipment for firefighters, for example. Then there's missions that require more and more power as they become more and more capable. So developing the solar panel technology to power those missions, well, we're going to need a heck of a lot of solar panels on Earth, and they're going to need to be efficient. That kind of thing, by driving these really difficult problems, you motivate them with an interesting question, but then there's always a commercial and humanity-based benefit to that technology. As well, at the same time, in like scientific techniques, many of the questions I'm asking about Mars, I'm coming back to my Earth department and saying, have we asked this about Earth yet? And they're like, oh no, we haven't. Maybe we should try that. You know, it makes you think in different ways, and I think that's really valuable.
Yeah, I think that's a fantastic answer. You know, it's one of the questions that we as planetary scientists get a lot. It's like, why are we doing this and not working to cure cancer? Isn't it a waste of money? Well, no, because as Francis says, there's a lot of spin outs and they could be really useful. And it started back with the Apollo program in the 1960s and the 1970s. A lot of advances in materials technology and medical technology, you know, then became spun out. And there are things that we use every day now that were developed for NASA and in the space race in the 1950s and 60s that you just don't think about. And you don't know what they are until they get invented, and then they become everyday useful items. And solar panels are a really good example of that. Firefighting materials, the parachute that the Perseverance rover landed on was developed and manufactured in Devon in the UK. And it now gets used for a lot. Heathcote fabrics, they're great, love them. They get used a lot for personal protective equipment, but it also gets used a lot for sort of geohazards and being able to deploy that in emergency situations globally, so not just working locally. So it really is like one of those kind of global solutions.
And it's not just the space exploration side of things. I think it's also technique development with investigating materials in the lab as well. So we use, like Natasha was saying, sort of similar techniques that you use in the medical field. So obviously any advances that we make in the lab with technique development, so improving the efficiency of these techniques, will apply directly to how those techniques are used in other industries as well. I mean, there's also the sort of, you know, you can kind of think quite out there with this. There is a huge swathe of planetary science which is involved in things like asteroid deflection. And that's obviously an interesting topic when you're considering sort of protecting humanity. So NASA recently sent a spacecraft to a near-Earth asteroid, and they smashed the spacecraft into the asteroid and changed its orbit. And that's obviously really interesting from the regards of planetary protection and things like that. So that's a sort of bit more out there way of thinking about it, but it is, I think, relevant.
Thank
you. I can only add, for example, there are even things that happen in space still affect the Earth. So, for example, BGS, we have a magnetic team that works on space weather. So our electromagnetic storms affect communication system. So still.
How many of you have seen Armageddon, as it's been mentioned? I actually
So
watched
good.
it last night by coincidence. I have seen it before, but
Oh, but you're all missing out.
We actually all watch it once a week. Just like
you get inducted.
Bruce Willis. It's got Bruce Willis saving the world or trying to save the world in it.
It's a great film, but actually it's a terrible film. It's a very
It's
watchable
so
film.
good.
But it's the other way around. It's geologists who are trained on Earth being sent up to an asteroid to try and save the world, having never done planetary science. So it works that way too in the movies. My pad has died, but I have a couple of very specific questions that came in before it died a death. So Helena, what were you doing at Diamond?
What was I doing at Diamond? So Diamond is a synchrotron. So this is a particle accelerator. So I guess the famous one is, oh, you're going back to the picture. Is the famous one is CERN. Diamond is on a slightly smaller scale than CERN. So what you have is you have particles that are accelerating around, and then at certain points along this circular synchrotron, the beam particles gets kind of like sort of turned in a different direction, and you can then use that particle beam to do experiments. And it's usually really, really high resolution, much better than you would have in a normal lab where you've just got a room-sized instrument versus a sort of car park-sized building. It's absolutely massive. And so they have lots and lots of different experiments that go on there. A lot of medical research goes on there, particularly during COVID. There was a huge amount of research going on there with medical stuff. I was using an instrument which combines micro CT, which is CT is what's used in the medical field, with X-ray diffraction. So X-ray diffraction gives you some information about minerals present in the samples, but I was combining the two together. So it's actually non-destructive, which is not very on brand for me, but you were firing two different types of, two different energies of beams towards these samples, and you were getting sort of mineralogical data in the context of where it was from a kind of 3D perspective. It's a new beamline on, it's called Dia Dual Imaging and Diffraction. Really cool, really, really cool. Diamond's a really cool place. It like feels like you're in a sci-fi setting because you sort of go and the whole building is open and you kind of go and it's all in the basement, but you can kind of see the whole thing, and it's all sorts of like pipes and things spurting smoke, and
it's proper sci-fi.
It's really weird. It's very strange. And you work there, so when you apply for time there, you get given like a set of hours, but you normally basically work through the night because you only have a certain amount of time to do it. But every single of the beamline places that you work has a TV, so you end up watching like horror movies at 3 o'clock in the morning whilst your experiments are running. Yeah, or sleeping. But yeah, but it's great fun. I really enjoyed my time there.
Francis, I have a very specific question for you. And despite this dying on me, I promise this was their wording, not mine. How did you find the transition from geography into a more sciencey subject for your?
Ouch. I'm
Can you tell
not
us a little
going.
bit about your experience?
I'm not going to take offense to that. So I have always identified as a scientist. So I went in as a basically as a physical geographer. I will say I really enjoyed the human side. I think I learned a lot that I wouldn't have otherwise learned. But in a geography degree, do learn science. But I knew what my niche was. I actually started my geography degree knowing that I wanted to turn it to planets. So I basically honed those skills that were relevant throughout, and then carried on doing science in a sciencey field. Yeah,
perfect. I know it's a science. I'm just reading the words that came through. And a specific one for you, Alessandro. As Francis alluded to earlier, sometimes there's a bit of a contention between the Earth satellite data people and the planetary satellite data people because the resolution is quite a lot greater for places like Mars, not everywhere in the solar system. And there's also a big argument between we know more about the surface of Mars than we do the depth of our own ocean. Do you ever find that in your teams working with satellite data that, you're looking longingly at Mars data or Jupiter data and thinking, oh, if only I worked in these teams? And what are the best sort of data sets that you get to use day to day?
At the moment, no, I don't have any jealousy In the way that I think, especially when we talk about Earth, the good things is, I mean, resolution-wise, you can find good resolution, especially if you consider commercial data set, but the temporal resolution, so the amount of data in time for the same region, you can study how a landslide is moving or the physics about earthquake. Yeah, that's, I would say, of course, probably would be, if you say something, I work on planetary space, probably is more exciting when you...
Because everyone wants to be Bruce Willis, right?
But still, I mean, thinking that, yeah, you can use objects that are hundreds of kilometers above the ground and studying processes at small scale, it's quite shocking if you think, like, compared to 30, 40 years ago. And honestly, I think there are so many benefits that the technology will improve, so there will be always more data, better resolution. It's just a question of time. We cannot keep up with pace. Sometimes you essentially open Twitter and every day there is a new satellite, a new data. Yeah, sometimes that's the shame on the other side. There are too many data now around.
So we need all of you to be planetary scientists so you can help us get through this vast mass of data that we're constantly generating at a ridiculous rate. Okay, I have a more general question for everyone now. Lots of people are asking very similar questions, which are basically, how do I get a job in planetary science? And what are the jobs in planetary science that aren't just academic posts? So not entirely the right crowd to be able to answer this one, but we will do our best because there are a huge wealth of opportunities. We've already mentioned the European Space Agency. They do an early career and a young graduate training scheme. So there's lots of opportunities there on both science and the engineering side, because you might be doing a geoscience degree and you don't love geology. You have lots of transferable skills that could go and be used in something else. So the European Space Agency is one example, the UK Space Agency as well. We do have our own, and we have a Space Force. So they have a lot of employment opportunities. But more generally, from your experiences, those transferable skills, and where do you think the jobs are for people that are interested in these fields?
Well, sorry, I've assumed that.
Yeah, no, go ahead.
I think in this kind of field, you learn an awful lot, not only about the specific science, but also people skills. You know, you get to travel and present, and you do a lot of writing, etc., etc. And that's all totally transferable to every other aspect of life. But, you know, I know people who have a passion for space who are not planetary scientists. Like there's space artists who take like planetary data and turn it into art. The picture I had of the polar cap was made by a space artist. It's real data, but they've made it pretty. You know, so there's, if you think of another stream of work that you're interested in, there's probably a way of adapting it. Like education, for example, you might not want to work in a university setting, but as a teacher, you could inspire students with this kind of thing. So I think, yeah, there's plenty of opportunities, and all of this data is free, so you can basically do what you want with it.
Helen?
I think another one that quite a lot of people who I know who've done planetary science or have backgrounds in planetary science is science communication. So because planetary science tends to, you know, people get excited about it and want to hear about it, you end up kind of talking about it quite a lot in outreach programs. I think that our experiences of science communication really give us a sort of skill set which enable us to go into those fields if we so choose. So that's a really interesting other application of kind of the field, because, you know, people get excited about space, so we all practice it. Like I say, I do a lot of outreach, so I think that science communication is a really interesting application of some of the transferable skills that you pick up whilst doing planetary science.
Absolutely. Alessandro?
Yeah, for me, it's, I think over the next, I mean, the UK government is investing a lot on space science. So they published the UK space strategy, and essentially, I think where we lag as a Europe in general, we don't have a very proactive and strong commercial, let's say, sector in terms of space exploration, like the US, for example. But I think this is going to change. The UK, I think, is the only spaceport in continental Europe. Yeah. So I think more and more over the next few years, there will be more launch from the UK, which means more, even smaller company will start thinking about investing. Consider also, yeah, staying talking still about the Earth. I mean, we talk about Earth observation, but consider that 3/4 of the satellite are not for Earth observation. They are for communication, for example. And then there are also military satellites we don't even know the existence. So, but they will still require our skills, essentially.
Fantastic, thank you. Well, I'm conscious of the time, so I'm going to bring this to a close. So massive thanks to both Alessandro, Helena, and Francis. And thank all of you for a really lovely lively discussion in the room and online. Thanks to everyone. We're heading for a break now. So if there's something you still want to ask us, you can grab one of us during the break. We're going to be easy to find. We're all very happy to talk about space, as you may have realized. And I have one final note for you that entries for the treasure hunt must be submitted during this break. So if you haven't done it already, you can quickly grab a sheet from the registration desk, hand them in, and we'll be drawing it at the end of the next session. So we'll see you back at 4:15.
Right, yeah.
That's yeah. Yeah. Yeah, I'm Liz. Nice to meet you. Okay. People have gone home. Might be the most popular. Yeah. But I know the Portsmouth people have to go at 4:30. Yeah. Sorry? All right. No pressure. Not looking in that direction. Passing thought, yeah. I think it's Oh, it's okay. They're all right. All right. Yeah. Yeah. Put the prizes in here. Okay. Prizes, everyone. Prizes. Even Ruth's abandoned me. Okay. Good afternoon, everyone. How are we all doing? How's everyone feeling? Everybody tired? Yeah, I know a few of you might have to go early. That's the Portsmouth students. Yeah, so feel free when I know you don't miss your coach. So please, make yourself welcome to go. So thank you all so much for staying to the bitter end. So we've got a few more, another panel session. And then we have the presentations of the bit that you're all waiting for, of the prizes. So my name's Liz Withington. I'm Principal Engineering Geologist at CC Grand Investigations in Gloucestershire. And I also have the great honour of being a council member, which I've recently taken up. So thank you for listening to me. So this talk, we talk about how as human populations expands, so does the range of interactions that humans have with the natural environment. Some of these interactions pose a hazard to human safety and well-being, and other interactions that humans may pose a risk to the ecosystem, such as contaminating the land, land instability, that kind of thing. So skills, research and knowledge in the earth sciences are vital to minimising the risk of harm. So on the panel, we are very privileged and very welcome to have several speakers. We have from the areas of hydrology, ground engineering, geotechnical and geoengineering. So I'd like to introduce you to Rhiannon Marchie-Smith, Ross Goodband, Joelle Way and Josie Whitehead. So first up, please, Rhiannon, thank you.
So hello, everyone. Obviously, Rhiannon, and thank you for the nice introduction. I'm the lead hydrogeologist of basically a project led by Gateshead Council called Project Groundwater Northumbria. It's a very formal photo of me, I do admit, but yeah, this was from the launch event back in April. So yeah, my background is in environmental geoscience, and I did my MSc in hydrogeology. This makes it look a lot neater than what my transition journey actually was when I did environmental geoscience. So I didn't know what I was going to do. I hadn't chosen hydrogeology. I was going to do geochemistry. So by a very uncertain path, this is where I ended up. And that's sort of the summary of my career to date in general. So when I graduated university, well, during my master's, I was meant to get a job as a hydrogeologist and sort of accidentally fell into a job in civil engineering, which has led me probably to this panel. So I got a job as a hydraulic modeler in urban drainage design, and that sort of was in civil engineering. So from that, because it was surface water management, but during COVID, I sort of had to find my way to escape the job. But it had obviously forced me into a hydrology path, but wanting to go back to geology. So I was offered a job at the Coal Authority, and I had the opportunity to do, so across the Northeast, we developed a hydrogeological conceptual model of the Northeast coal field. So looked at the connectivity of the entire mine workings. So we wrote a report on that, and I was quite lucky to be involved with 2 other people on producing this industry report, and also looking at mine water levels to inform SUDS designs, which links back to that previous job. So by sheer accident, I sort of found this link and niche between the two. So after that, because it was a temporary post, I got a job in more operational mining and water management. But because of my background, I sort of was forced again into the surface water management side, and doing a lot around pit slope stability, channel design, and that kind of thing. So it's a really interesting way to lead to where I currently am, which is sort of as the PGN lead hydrogeologist. So the interesting thing about this project is it's essentially looking at the interaction of urban drainage, northeast mine workings, the geology of the northeast, and obviously trying to apply the knowledge around how you model mining and surface water management in that context. So I'll give you a little bit about the project. So the great thing about it is it's a publicly funded project, so all the information is open to everybody. So it's part of a £150 million DEFRA funded FCRIP programme, which is basically the Flood and Coastal Resilience Innovation Programme. It's running until 2027. So the project that I'm on is one of 3. So this is ran by Gateshead Council, looking at groundwater and mine water rebound. And what we're aiming to do is develop a forecast and warning system to predict flood risk in the area. Then there's a couple of others across the country where they're looking at the flooding in the chalk and also the flooding in the limestone. So the thing in this project, so my role kind of spans between 2. And I guess that's where this transition has kind of happened in career progression, where it's kind of encapsulated a lot more project management. So overseeing the 3 work streams where you get to see across the board. So looking at improving the geological model that I did previously, drilling new boreholes to get more information, so overseeing a work stream on that. And also this design system, so then we can also build the model to design new solutions, which works directly in tandem with, if anyone knows about the mine water heat schemes that Gateshead Council's running, if we can use mine water heat schemes to manage flood risk in the area. Thank you.
Thank you. So thank you very much, Rhiannon. And next up we have Ross. Thank you.
Hi, my name's Ross Goodband. I'm a principal geoenvironmental engineer at Pick Everard and a graduate from University of Portsmouth. So Portsmouth guys, I'm really sad that you're leaving soon. So I graduated in 2022. No, I didn't. I graduated in 2012. That's a typo. Not that young, I promise. I graduated in 2012 with a BSc in geology. How do I flick to the next slide? Green button. Yeah. Awesome. So I misunderstood the brief and I don't have as many pictures as everyone else, so I'm sorry. I graduated in 2012 and got a job as a graduate contaminated land consultant at Arcadis, and I specialised in site investigation and in situ site characterisation. So that's things like blasting lasers into the ground to make oil fluoresce and work out how much oil's in there, or heating it up and forcing the contaminants to volatilise and pumping them through a gas chromatograph in the field and seeing how much is there. After that, I moved to work for Raw Group, who are now RSK, in pollution response as an environmental scientist. So I spent a lot of time cleaning up oil spills. And then my last job there was completely out of the blue, working on a 5,000-ton slurry spill into a river. That was less than pleasant. Before moving to Patrick Parsons for a year to become part of a new team working in London. After that, I got a job at MEC Limited, again, working back in ground investigation and contaminated land, doing lots of site investigations for housing developers and people like that. And now I work at Pick Everard, heading up our contaminated land team. So mostly looking at legacy contaminated land issues on a lot of public sector projects. Pick Everard is mostly public sector clients, so doing work for the government or local authorities and various different departments, dealing with legacy contaminated land issues across the country, in advance of development, or occasionally dealing with some Part 2A work as well. Thank you very much.
Okay, thank you, Ross. So next up, we've got Joelle, please. Thank you.
Hi, everyone. Yeah, my name is Joelle Way, and I'm a senior geoscience consultant now at Marine Space. My background was geology. I graduated in 2015, and I decided to stay on and do a petroleum master's. I was very fortunate to get a scholarship to do my master's, and I really encourage you guys to speak to universities and see what you might be able to get out of your university as well. See if you get any funding that might help towards any further career development. Yes, that's me graduating, and I also was asked to do a engineering article for women working offshore, and that's me on a sunny day offshore in the North Sea. So I've done a very clean curve here, and really it should be an absolute squiggle to get to where you want to get to. So I obviously graduated at Royal Holloway, and then I did some various temp work, had the very high expectation that I would get a job very quickly after uni. And that's something that I would encourage, to make sure you don't have such a high expectation. I think just really develop your soft skills and find something that you think might be transferable. I never thought I would get to where I am today, which I'll go into. So I took a GIS-based role at a company called Scient, and didn't actually like GIS at the time, but I took it, and I got my foot in the door at Fugro, and that's where I did a lot of my offshore work, and also worked onshore. So mainly working in the core laboratory labs. We're looking at cores coming in from offshore. One of the interesting projects we did was for Nord Stream 2. So we had to actually wear gas masks to make sure we weren't going to get contaminated by nerve agents and yeah, obviously dirty chemicals that were dumped in the North Sea. And yeah, another project I also worked on was Seagreen, which you might have seen in the news recently. That's now a developing offshore wind farm. And so I did 4 years at Fugro, offshore and onshore, and then I eventually got a job at Marine Space, which has now been part of ERM's group. And I work in more of doing like cable risk assessments and a lot more geotechnical kind of based. When I was at uni, I was very sort of geology tunnel visioned. And yeah, I never thought I'd even look at geoengineering today. I think as soon as you sort of get your career off the ground, there'll be so many opportunities that you don't even realize existed. So yeah, just be open-minded, and yeah, hopefully you'll get somewhere that you're happy. So yeah, I'm very happy where I'm working now. And I just put in some pictures of some soil samples we did, and some will be sailed to an offshore platform. And it's a drilling vessel, and one of the labs we used to work with offshore. And that's a little bit about my career. Thank you.
Thank you, Joelle. And finally, please, Josie. Thank you.
Hello, yes. So yeah, this is me. I'm Josie Whitehead. I'm a geotechnical engineer at Jomis Associates Limited. We're a site investigation company. So similar, I've got similar background to Ross, but just at one company in my case. I studied geology with study abroad and graduated in 2016 from University of Bristol. This one? Oh yeah, so we go. Yeah, so here's just a bit about my background. I graduated in 2016. Like Joelle, sorry. At that point, I thought maybe I'll be able to find a job easy, and I wasn't able to. So I did some local work near where my parents lived, just temp work, saved some money, and then I went traveling around Australia. I'm sure with a room full of geologists, you all understand why I would want to go to Australia traveling. It was obviously amazing. And then I came back, and in 2018, I started working at Jomis. So I initially went into a role as a geotechnician, which was primarily a site-based role. A little bit about site investigation. So there's the contaminated land aspects, which Ross was talking about. So that's doing surveys, pre-planning to, yeah, basically contaminated land surveys, which are required for planning requirements. We also do geotechnical aspects as well. which is looking at the properties of the soil and rock and using that to inform like foundation design, look at earthworks, that kind of thing. As a geotechnician, when I started at JOMUS, I didn't know anything about site investigation. When I was looking for jobs, a lot of site investigation jobs came up. I didn't really know what it was. I went to the interview with JOMUS and still didn't really know what it was apart from looking on the website. But I went for it because it seemed like a really interesting job, and it was new things that I hadn't heard about before going for that interview, basically. So yes, I was primarily site-based. JOMUS is quite a small company. At the time, I think we only had about 12 employees, but we had about over 50 projects on the go at one time. So my experience of site work was a lot of small projects, a lot of different site visits that were varying types of work and varying locations as well. Sometimes you'd be in a empty field, some days you'd be on a petrol station. It just, very varied and really, really good hands-on experience, basically learning on the job, learning so many new skills that way. So as a geotechnician, I hadn't specialized at that point. And then in 2019, I was given the option to specialize as either a geoenvironmental or geotechnical engineer. I chose the geoenvironmental stream. I had actually not really done any geotechnical work at university until my master's year. And I had a really big interest in geophysics. And I did a master's project that was using geophysics to try and determine geotechnical parameters of the soil. At this point, I'd never really looked at soil, very much rock focused, but I found it really interesting. So when I was given the opportunity to specialize down the geotechnical stream, I was like, this is brilliant. I've vaguely thought about this in the past. So yeah, that was the point I chose to specialize. But at that point, I was still primarily site-based. I did, I'd say, 2 solid years of site work. And then it was in 2020 that I started doing project management. So I was the one sat in the office on the phone to the engineers who are on site, helping them out. But I was still doing some site work at that point. And that's then I then progressed to be more desk-based and more of a project manager and working on the report writing side from 2020 onwards. And I've been at JOMUS since then. I'm still there. I've just put a few pictures up here of things we do. So with site investigation, majority of the time you're drilling boreholes to get samples of either soil or rock, depending on the ground conditions. So this is a cable percussive rig here, and that's a windowless sampler, both drilling rigs to obtain samples. Here's a rock core. I'm sure lots of you have seen rock cores before as well. With a lot of site investigation work, especially the contaminated land side, you're often looking at more shallow deposits. But in some cases, we do drill deeper and drill down into rock. But a lot of the time, it is more soil. So it's good when I do get to see rock cores. But yeah, that's just a bit of my background.
Thank you very much. So that brings to the end our speakers, and we'll go over to questions. Thank you. You're more trained than I am. Thank you. Okay. So,
and then you can.
Okay.
Promise it.
Yeah. Okay, so we're looking for some questions on the Mentimeter, and we'll look for some questions out in the room, please. So, you got any questions out in the room? I've got a question. If I go quick round through the panelists, what was your most memorable project?
Good question.
What's the one that you enjoyed the most? Yeah.
Oh, enjoyed the most. Well, there's a lot of memorable ones on petrol
I think more like the rock logging side using a rotary rig. There was a site in the Cotswolds where we were drilling through oolitic limestone, and I think with site investigation, you're often thinking about the geology, but not necessarily seeing the rock, more just seeing the you know, soil or superficial deposits that are, so I think I would say, drilling through that oolitic limestone. I still have the cores in my garden at home that we had the excess cores. I was like, I'll keep hold of these ones.
It is hazard in the job, isn't it? to squirrel away things.
Yeah, Rianne? Very similar. I have a lot of memorable projects. They're not necessarily always memorable for the right reasons. There's one that I hated, but I probably learnt more from it than any other, which was it was only the second time I'd used SAPW. So you're kind of modeling groundwater, surface water interactions, but it was for a block cave in Australia. And there was no senior to support me. So I had a very steep learning curve on how to use it. And I can look at it now and know exactly what it's doing. Was the experience pleasant? No. The project was really interesting, kind of the size of the mine, and also with block caving. Don't know if anyone knows what it is, but you're kind of looking, and it's basically underground mining, but using gravity. So like an open pit, so letting it collapse in on itself. So it was very much unsaturated zone modeling, dealing with the soil and that kind of thing. So incredibly interesting, but equally painful to do.
So as a graduate, I spent about 6 to 8 weeks in Europe working on a project for a pesticide company. They were looking to relicense a couple of their pesticides, and you can either do it with fancy complicating modeling proving that your pesticide breaks down in the environment and isn't going to impact anything other than the pests it's designed to kill, or you can ground prove it. Once you've had it licensed once, when it comes up for renewal, you can ground prove it. So the pesticide company paid a lot of farmers in Europe a lot of money to have boreholes drilled on their land and for us to go back and monitor the breakdown of this. They even gave them free pesticide for a year to monitor. The farmers loved it. To monitor the breakdown of the pesticides in the groundwater and in the soil over the years. And it was an interesting project from that point of view. It was a bit of a pain because it has to be run like a science experiment. You have to treat the field like a lab. And if any of you have ever walked through a field, you're not allowed to get your equipment dirty, which is really hard with a drilling rig. Also, my handwriting is appalling. And every time I had to make a correction, it had to be dated and noted and put in the log. So there's a lot of corrections, but it was a really interesting project across Europe. I've got memories of digging a drilling rig out of the snow in December, or being in 40-degree heat in Hungary in the summer, and it was lovely. The people were lovely. The food was amazing. And the farmers were just happy to be there because they were being paid a fortune by the pesticide company, and they'd got free pesticide for the year. It was everything they ever wanted.
I think mine's a bit more simpler, but I suppose I worked, as I mentioned, on the Nord Stream 2, and that was quite challenging because we had to wear the gas masks, and every 10 minutes we had to have a break, and we had sort of bomb disposal unit on standby, scanning all the cores and making sure that we were safe and the lab was safe. So that was probably the most interesting project I've worked on, and also going offshore, working in the Barents Sea. That was a great opportunity. I worked on 24-hour daylight situation. So at 6 in the morning, no, about 3 a.m. the sun was basically still out. So it felt like a very long night out for the whole month. But it was a really great experience, just going traveling, working in different environments. And
Thank you. Yes, please.
So firstly, thank you very much for your presentations there. I notice you're all very, very experienced and shared very well on your experience to date. I wondered, just curiously, is chartership on your horizon? And I mean, I've got several years of experience, and I wondered, from your opinion, has there been any barriers to yourself? What's your view on that? And what would you tell everyone, what you would have liked to know, at this, starting off in your career about chartership there?
I don't mind going because I'm going through the process at the moment. I think the key thing is, and I know when I've spoken to my mentor, and probably what you don't think about so much early on, is about getting the diversity of exposure that's needed for chartership. So I think even though my career to date is in a short space of time, because I've job hopped quite a bit, it's given me the opportunity of exposure. So I'm trying to collate it all together to submit, hopefully in January. But I think that's the key thing. It's how much exposure you've got to different problems and different, not necessarily industries, but in a way where it crosses over and what your specialism is within that. Because I guess when you apply, you select a specialism. So what you've seen across that, because I think sometimes in consultancy, you might have to kind of push forward yourself because you can get a bit stuck on the same types of projects, and you might have to be a bit proactive to try and get other types of projects to be able to reach chartership.
Yeah. I'm also going through the process at the moment and hopefully submitting in January, although I've said that for the last 2 years. The biggest thing for me is historically in contaminated land, the guidance has been a bit vague because it's a relatively new area for chartership. Now there's a lot more guidance on there, but that being said, I've been a fellow since I graduated, and the moment I got a job, it was one of the first things I did. So I think from my point of view, it's just mostly collating all of that CPD. It sounds like a scary thing, but in actual fact, almost everything you do, especially as a graduate, everything you do can go down. At the moment you learn something new, it can be CPD. It doesn't even have to be geological. The first time you learn to write a risk assessment for walking through a field, stick it on there as CPD, because that's all relevant.
If my line manager was here, I would say, yeah, I'm definitely going towards chartership. But yeah, it's a very slow process. But best advice I can give is if you're passionate about doing it, that will motivate you to really get the chartership. And I am obviously passionate. It's come across the wrong way saying that. But I think the best advice I can say is even now have a bit of a log behind you of like what field trips you've done, what skills you might have learned on those trips, and what modules you've studied, and just getting even just an Excel spreadsheet of what you've done basically throughout your undergraduate. That would just help be a bit of a probe as you go into your career. You can use those towards your chartership points as well. It's really hard to sort of dig back in your memory to go back to when I couldn't even think of most things I've done then. So yeah, that's the best advice I can give, is just log as much as you can, and yeah, save it twice. Thank you.
I do have a point on the back of that I'll just add. It just reminded me on the back of what Ross said, and also Joelle. I think the key thing that can be a challenge is around the evidence. And you sort of have to, when you're logging it, you also have to pay attention to what you're working on, because you collate about 5 pieces of evidence. That's essentially a portfolio to go in for chartership. So, and it's quite curated. So I think you have to be quite intentional when you're going through your career building up to chartership. You're thinking about what you want to put together as your portfolio to submit in alongside your CPD.
Yeah, I can add to that as well. So if you all become student members, then get access to the CPD, which is all online, and then you can start to think about where you're going for the year, start to build your CPD, but you can also add in your documents there. So they might not be what you submit at the end, but you've got them there to hand through the process. So I would really recommend, firstly, student member, and certainly using that CPD record, keep adding to it all the way through. Okay, thank you. We have a question. Okay.
It's a bit of a question for the group on this one. For people who are here maybe doing a pure geology or geoscience degree, what are the different routes to get into engineering, geology, geotechnics, or geohazards? Because I know everyone's got a different way, and there's different ways of doing it. But for people who are maybe doing a pure geology degree that are interested in getting into it, what options are there out there?
I think so I did a pure geology degree, and I had actually looked at geology of planetary science, and I thought to myself, I was at that point I wasn't sure, so I went for the pure geology stream. And as I said, I was really interested in geophysics, and I happened to do a bit of geotechnical work within that, but it was only within my master's project, so I didn't actually do any engineering geology work in my degree at all. So not that I can think of through my undergrad or in my master's, but it wasn't a prerequisite for the job for site investigation work to have done that. There are people, my company, who are geologists, environmental geoscientists, straight geologists and geographers. Sorry, I meant to say geographers. And they've all, been able to get into the role that way. So I think, with site investigation, there's not necessarily like specific modules that you need to be studying, but I do know that if a lot of engineering geology masters will then help you, and some of my colleagues did do engineering geology masters, and so they knew more about the discipline before they joined, but it wasn't a prerequisite. So it is possible to get into that from anywhere, basically from having any sort of geological degree, I'd say.
Kind of similar. I didn't intentionally go into it. It seemed more of an accident that I sort of led that path. And I think with hydrogeology, I've had this discussion quite a few times today. There's two sides to it. And I think particularly in the UK, it's a lot more heavily focused on water resources and contam land, which obviously crosses the two. And then on the other side, you have the engineering aspect with mining and with construction. And it's where obviously groundwater is a problem and you need to get rid of it. And I didn't intentionally go down that path, but I didn't really get much exposure to it when I was at university, because it was always more about the environmental aspect and the protection. So I think in some ways, it's about identifying what's interesting to you. And I guess that's the benefit of days like today, to hear from different people and different avenues you can go down, but just what might be interesting to you in a different industry across the board and going from there. But I don't think it matters too much. And as you've said, that you've not had much experience within your degree itself. You can get that postgraduate experience, or even in my master's, I didn't have a massive amount of experience within a grad scheme. You'll get that training anyway.
Yeah, I mean, so I have a pure geology degree as well, and I interview graduates for graduate roles at our company. Geology is such a broad subject, and then obviously if today has not shown us enough, like individual industries are quite niche. And I think the best example, geology gives you a really broad understanding of everything, and then you go off and apply for a niche industry. So when I interview people, I'm not necessarily expecting them to know the ins and outs of contaminated land or geotechnical engineering. I'm expecting them to know the basics of geology, which you'll pick up on your geology degree, or if you've done environmental science and you pick the right modules, or geography and you pick the right modules, that sort of thing. I'm then going, right, after that, once I know you've got the basics, are you going to fit in? Are you good at working at a team? Can I put you out next to a drilling rig with two 50-year-old grouchy drillers who might kick off if you ask them to do the wrong thing? Are you going to be all right in that sort of situation? And can you learn what I can teach you? And as long as you can tick those boxes, I think you're fine. As long as you can demonstrate it, you will learn, you will fit in as part of the team. Geology has taught you the basics. We'll teach you the rest.
Yeah, so my undergrad was geology, and I was very focused on that. I want to be a geologist, and I had kind of tunnel vision. But the more I sort of got work experience, it opened up so many other doors that I didn't even realize were out there, certain sectors that I didn't even realize were out there. So I think depending what path you go down, you'll probably find a completely different door to your friend sitting next to you. And I think just be open to taking as many sort of different opportunities as you can. I look back on my career path, and if I told myself as a graduate I would be doing that, I would say no way. But it just your career would just evolve naturally and into something you may have thought of when you were younger or not at all. So yeah, it should be exciting to see where you're going to end up, basically.
Definitely, I'd add to that. Say yes to every opportunity. Like, definitely grab everything that comes along and just see what happens.
You can, a job's never forever, as I like to say. Like, you can do it for as long as you like, and it'll open up many other doors further down the line.
Thank you. Do you have any more questions in the room? I'm not getting any on the Mentimeter at the moment, so
Too late in the day.
Thank you.
Yeah, hi. All of you have had quite varied careers and early careers and stuff so far. How did you find that period between graduation and getting the first step on the career ladder where, you know, everything's a bit up in the air and it's a variable amount of time for like each person? How did you find you kept your focus on trying to get a job in that time?
I remember it being quite traumatic. I was living at home and working in a calendar store of all places. So a friend of mine got me a job in a calendar shop. And then when that came to an end, I went to work for Clinton's Cards for a little bit, and just all the way while I was doing that, applying for jobs, you know, looking and applying for jobs that I was interested in and begging for time off from these jobs that I'd been there for all of 2 weeks. And I really need tomorrow off to go for an interview in Cambridge or in Aberdeen or wherever it happened to be. And accepting as well, like as a geologist, geology companies are all over the country, and accepting as a geologist that I'm going to have to travel for work. I think, you know, if I'd said, because I grew up in Leicester, if I'd said I've gone back home to Leicester and Leicester is where I will stay, I think I would have limited myself massively. The fact that I was willing to go that I want a career in geology and the interesting rocks aren't in Leicester, unfortunately. You know, I will go anywhere. Yeah, it is a little bit, sorry. Yeah.
I think I also found it a bit traumatic. I was working a temp job when I got back from Australia, and I just didn't have the motivation to go out and find that job in geology. I sort of settled into that, living back with my parents, and it was quite easy to just stick with that. So I said to myself, Christmas, I'll quit this job and I will just job hunt and I'll find myself a job. My parents said, that's fine, you can not work for, you know, find a job. It took me 4 months and it was tough. And the thing is, you can't job hunt 24/7. You can't do that as a full-time job, you know, 7 hours, 8 hours a day, because first of all, there aren't that many jobs out there. And it's can be quite hard. So I think it's just reminding yourself that as long as you're trying and doing what you can, you don't need to be, you know, like really burning out trying to do it and putting yourself down, because it literally just depends on the market at the time. It depends how many jobs are out there, how many people are looking, and it can be quite hard. And I guess probably also what time of year you're looking will also affect that. If you start looking just after you've graduated, a lot of people are going to be looking at that time. So trying to look before you graduate, or, you know, yeah, or work it into a different time of year, but that would definitely help as well, to just sort of make it a bit easier on yourself, I think.
I was probably a little bit different because I think because I did a master's and that runs through to October. So I was applying for the jobs for the grad schemes at the same time as doing my master's. So having to balance that. It was still slightly traumatic because I didn't intend to go in as a hydraulic modeler. I'd been offered a job as a hydrogeologist, and kind of last minute, they were like, oh, we've got no project work. And there was obviously a dip in the projects at the company. So they were like, but do you want to do this? So the job they initially offered was in Redditch, and the alternative job was in Newcastle. So much like you said, it was like, well, okay. And it was a bit late in the day, so I needed the money, but kind of got to the point where I was trying to finish off my dissertation by the end of September, started that job the 1st of September. So it was a bit of a pain, but I didn't have that gap in the same way where I wasn't working and searching. But as you said about time of year, I guess because a lot of the grad schemes open up at the same time of year, and they're all kind of early, kind of just into the new year. So if you're looking while at university or doing a master's, that's usually the time everyone starts applying. But yeah, it gets a bit more disparate, I guess, as you get into summer.
Yeah, I'd say it may be a bit of a shell shock situation for some of you, but I think just don't put so much pressure on yourselves. I think it's very rare for you to sort of finish uni and walk into the perfect job you always want. It is a lot of ducking and weaving to try and get to where you want to be. So yeah, I think just don't put too much pressure on yourself and be open to lots of opportunities. Try something new, and I guarantee you'll look back and think, well, that was a transferable skill. So I'm really glad I did that at that time. So yeah, I think just try not to put too much pressure on yourself and specify. Yeah.
Thank you. Thank you. I think there was another question down here. Yeah.
So you mentioned that you worked in legacy sites. I was curious to hear what was some of your difficulties and challenges on working on those types of sites, and how did you overcome them? Because I know that working on legacy sites can be quite difficult.
It can, yeah, especially if the person who caused the problem is no longer around. The organization or company isn't around anymore. They've just done horrendous things to this patch of land and then left and made it someone else's problem, which is more common than you'd like. And a lot of it comes down, so we go through what's called the desk study phase, and a lot of that is trawling through historical maps and public information. And I'm not lying, I have Wikipedia'd the odd site as well, just to find out anything and everything you can, to find out what sort of contaminants are likely to be there, because you could test for literally everything, but that's very expensive and not what we're looking for. So we want to target our testing as much as we can. So one of the worst legacy sites I worked on was Sanofi Dagenham, which Sanofi is a pharmaceutical manufacturing company that had their Dagenham site since before the First World War, and they used to make cancer chemicals there. And so obviously people didn't care about the environment before the First World War, and for a long time afterwards. So a lot of stuff got buried. And not the best situation, but there was a huge amount of stuff there. And I remember the project team, and I was a graduate at the time, and I remember the project team trawling through huge amounts of information on the different chemicals that they'd used, the different drugs that they'd produced, any vague records of disposing of material that they had, to work out what we could test for. And we went from a very, very broad suite of contaminants that we could test for to a still quite broad, but less broad suite of contaminants to test for, before then designing the remediation techniques and everything that would go into that. I've also done work on landfills, and landfills, again, are quite difficult because a lot of stuff can get dumped in a landfill that you might not necessarily have records for. And that is exactly where the broad brush approach comes. We're going to test for lots of things and let's see what we find. And again, you might have to trawl through records. Modern landfills are permitted. They're only allowed to take certain things, and they're only allowed to take up to a certain threshold. Landfills before then, not permitted or less permitted, and they'll have taken anything and everything. Municipal landfills, again, they're only supposed to take municipal waste, so household waste, and you're only supposed to put certain things in your household waste. How many of you have thrown batteries away in the past, you know, or you know, bits of metal and things like that you're not supposed to put in your bin, but you do, and they go all the way through the system and they end up in a landfill, and some poor bloke's going to dig it up with his digger later when the housing officer decides that that's exactly where they want to put the housing development. So yeah, you do get lots of challenges. And then access as well. Lots of derelict sites get taken over from people. So I've worked on sites where a load of travellers had set up and taken over. I was busy water sampling, and I was sat in my van scribbling on my notes, and a horse put his head through the window. You just turn around and he's there and he's busy munching on my paperwork. Just like, so yeah, challenges are varied.
Thank you. I've got one question, another question on the Mentimeter here. If that's okay. So would it be possible to get into geoengineering, geotechnical jobs without a strong numerical background? That's one for Josie.
I mean, yes, I would say yes. I think like recently I've started doing more like varied reporting, I guess, and we're starting to use more modeling software and take on different types of assessments that do sort of require that numerical background. But when I started in my role, that wasn't a necessity. I learned so much on the job, so much of what I did to start with. Like I'm assuming in most companies you will do site work to start with if you're working in site investigation or other geological engineering sort of jobs. So you can pick up so much information through that, which just then helps you, leading you into the report writing side. But it does depend. If you like at Jomus, we don't do a lot of really specific assessments, or we're starting to pick those up. But if you, in some companies, maybe the geotechnical aspect would be very numerical based. So I can't comment on other companies, I guess, but from my experience, so much of my knowledge and experience is from site work and progressing through and like sort of slowly needing to be more analytical, I guess, and that, yeah, having that numerical sort of background. So
yeah, just want to say that when you're looking at job applications, don't be disheartened that you can't do absolutely everything on the job application. It's so common that people look at it and think, I can't do 100% of this, let alone 80% of this. I'm not going to apply. That's not the case. I think you just get your CV in. There'll be skills that you can use and just try and sell yourself what you can do on that application, and you'll be surprised. It's never 100% criteria.
But I think I think it's also remembering that when you're applying for a job, it works both ways. So if you get the interview, yeah, I don't think you need a strong numerical background per se. And I think as a geology background, you have a numerical enough background, but it's not like strongly, you might not have done loads of modeling and that kind of thing. But asking the question about what the role entails, like how much site work are you expected to do, how much modeling, or is it kind of a hybrid between the two? I think just getting a sense for you, like what you'd prefer to do, and asking those questions in interviews.
Thank you. I think we're probably just about out of time. I can't see. Looking for somebody. Oh, you're there. Yeah, so we're just about. So that was really, I really enjoyed that actually. So thank you very much. There will be a final networking session after this session closes, but we're just going to have a few closing words from Ruth, who you've met previously, and Simon Thompson. So, and then there's a good look in the prize draw after that. So, thank you. Swap seat. Thank you. And have you got some? Okay.
Might need your might need your help with prizes. I'm going to give the prizes to Ruth and she's going to do them. Okay. Hello everyone. Great to see you. Thank you for staying. My name's Simon Thompson. I'm the Chief Executive here at the Geological Society, and I'm here with our President, Ruth, and we're here to say a few final words, and then Ruth's here to do the interesting bit, which is give out the prizes. So it's been a fantastic day. I've really enjoyed myself today. It's been great hearing from inspiring geoscientists, engineers, and others. You've seen that the geoscience community is varied and dynamic. There are careers to suit all types of people. By choosing, and I can say this next bit because I'm not a geoscientist, so it doesn't sound too boastful, but by choosing a career in geoscience, you're choosing to make our world a better place. You'll be helping to make it safer, more sustainable, and more prosperous. So Ruth is going to be doing some thank yous, but I want to thank you for joining the geoscience community, and thank you for today for engaging so well in today's event and making today such a success. I think we'll all come away from today with optimism and with faith that the future of geoscience is in good hands. So I'm now going to hand over to Ruth.
So as Simon said, he's the chief executive, so he's the actual boss. I'm here today and gone tomorrow. My term is 2 years and it finishes next June. But Simon's not been here very long, but he is the boss. So thank you very much, Simon. I've really enjoyed the whole day, and particularly talking to those of you who I spoke with. For those of you who couldn't find me for the quiz, I'm really sorry. I did take a few little breaks to get some quiet. The answer to what my favourite rock is, it's the rock that was depicted on my opening slide. It's the principal constituent of cement, or the principal raw material for making cement. Some of you thought that might be gypsum. No, that's what you make plaster with, and plaster of Paris and so on, and various other things. But the answer is limestone. The reason that's my favourite rock is partly because I've spent a lot of my career working with cement raw materials and the design of quarries to recover them, but also in all its forms. It's absolutely fascinating, often very beautiful, very often has some fantastic fossils in it. If you've ever been to the Jurassic Coast, you'll know that. Some limestones are wonderful for creating sculpture and beautiful buildings. So that's why I chose limestone. So just looking back for a moment, today we opened the event with an energy transition panel, hearing from those who work in renewables, oil and gas, mining exploration and mining geology, and a few other things besides. So we got our first glimpse of how our panelists in all of the sessions have somehow sometimes had ziggy-zaggy paths to where they're currently settled, and some have gone straight to where their passion takes them. Inspiration strikes at all sorts of times. We also had an introduction to creating an impactful CV. If you missed the first CV workshop, don't miss our final workshop of the day in 10 minutes if you didn't join that lunchtime session. We then had a panel on digital geoscience, where the panel came from different sectors to showcase increasingly important digital roles, a sector that's growing rapidly in scale and importance. And we heard in my panel, actually all of the panels, about the importance of the digital world and digital techniques to all of the sectors we're talking about. We had a climate and ecology panel, understanding climate change and its impact now and in the future, as well as researching and implementing ways to mitigate the impacts, are truly defining issues for our time. And you all got a flavour of what it's like working in this sector. We then had a literally out of this world session on planetary geoscience, which perhaps isn't an area that people initially think of as a geoscience specialism. And last but not least, we've just heard from the panel on geohazards, geoengineering and georesilience, considering how earth sciences are vital to minimising the risk of harm to us and the risk of harm to our environments. I hope we can all agree on the importance of these and many other career paths in the sectors we've showcased today. I hope you may be inspired by discovering or being reminded that geoscience is a key driver for the future of this planet. And as Simon says, with this level of enthusiasm and the amazing buzz we've had around the building, I really feel that the employers of today will be very lucky to have you with them. So keep persisting. There are a few things I hope you'll take away from today. Firstly, it's the array of various paths there are in geoscience and what you can do to really make a difference now and in the future. Secondly, it's how joining the Geological Society can support you throughout your career, whether it's utilising our online resources. I do, if you think our website's terrible, you're absolutely right. If you want to know something and you think it might be on our website, the best thing to do is to Google it. But a better website is coming really soon. It's top of the priority list. It's on its way. But I do apologise if you've been frustrated by that. It may be using the library online or in this building, coming along to our events, finding a mentor. Mentoring is so important. I've been absolutely enriched during my professional career, both by the generosity of mentors that I've had and also through mentoring others. and actually especially through mentoring others, because that's when I really learn more, and it's also a pleasure to give back. You might be volunteering on committees, as I have, which as I said before, has been a huge pleasure and incredibly beneficial. Or you may get involved with special interest groups, to name just but a few things. But now the bit you've all been waiting for, the prize draw. The prize, we haven't got, you know, something revolving and balls and things. I've got Post-it note. So the runner-up for the prize draw is Zachary Hansen. Is Zachary here? Yes. So here is your tote bag full of goodies. Some edible, some useful. And the first prize, and I'm going to have to apologize in advance to Yueju Zhang. So I apologize because I think that might not be the way to pronounce it, but no doubt you'll tell me later. Was that a passable way to pronounce your name? Good. So congratulations to both, and thank you for those of you who took part in that. It was really to help you, you know, break the ice and enjoy the day more. Just some final thank yous. Firstly, thanks again to our generous sponsors who have supported us with this event. I'd also like to thank the steering group for this event, who carefully planned the day, invited speakers and sought sponsors. And I'd like to give them a round of applause in a moment, but combined with that, another round of applause to all of the speakers and the session chairs today. They've given up an incredible amount of time, not only to prepare, but also to be here. All of them have been absolutely fantastic. So thank you very much. I also want to say a huge thanks to the amazing staff at the Society. Working with the staff is actually the best bit of being president. I'm so privileged to be doing this job. Almost everybody who works in Burlington House and some from our publishing house in Bath has got involved today. Those who have not been on show have been keeping the Geological Society show on the road in other ways, making sure, you know, bills are paid and the lights stay on and all of those things. Seeing them in action on a day like today, welcoming you all, informing you, ensuring that everything runs smoothly is truly impressive, and I'm really, really proud of you all. Thank you very, very much. A special shout out to Becky, who's masterminded the event. And a huge shout out to all of you, and thank you for filling our building with chatter and interest and wonderful attention, wonderful questions. Thank you for coming. Safe journey home when you go. I'm going to now bring this to a close. We've got a final networking session of the day and a drop-in CV workshop upstairs. So with that, I'll say cheerio. Thank you very much.